Hello. Am I audible?
Good morning,
Yeah.
sir. Yes.
Okay. Okay. We'll start soon. Okay.
You are audible.
Yeah. Just wait for some time. We will start. Screen is visible to all.
Yes, sir.
Okay. So good morning, all of you. This is Arpit Amrate, your Math 1 course instructor. Okay. So basically, in this session, we will discuss some sets, definitions of sets, some kind of sets, and relation basically. Okay. So what we will do in this session. So we will discuss basically week 1 content. We will try to cover up to relation, and the rest thing we will cover on Sunday's session. Okay. Am I audible, right?
Yes, sir.
Yeah, audible, sir.
Yes,
What
sir.
about the rational numbers and natural numbers? Will cover also these things.
No. It's obvious, right? It's obvious what is natural number, what is whole number. It's obvious. It's already covered on video, as well as it's already done up to 10th standard. I don't think so. It did that thing I have to cover. If you want,
I
I
have
can,
some
but
doubts.
yeah,
I
if
have
you
to
have some
clarify.
doubts, if you have some doubts, you can ask in this class itself, or beginning of the class or end of the class. It's up to you.
Right, sir.
But I don't think so. It's really need to cover those things, right? What is natural number? What is whole number? It's just 6th standard thing, 6th to 7th standard thing.
Okay.
So why we have to waste our time on that topics? But yeah,
But
if you have some doubt, you
it's
can ask.
yes,
If
sir.
you can,
Okay.
you can ask.
Right,
Okay,
sir. Thank you.
it's for everyone. If you have some doubts on number, you can ask in this class itself. Okay.
Right, sir.
So first of all, welcome all of you in this ITMBS program. This is our first session, most probably first instructor session. TA session has already done in Wednesday, I guess. Good morning, good morning, Avinash. Right? TA session is already done.
Yes, sir.
Okay. So this is your first instructor session. And one more thing, please let me know how many of you are not from math background. If you are not from math background, please write Y on comment box. Okay, Vishwamit, I will take that. Okay, just write Y in chat box. Okay, okay, fine. Okay, okay, okay. So I guess Math 1 content is already released, right?
Yes, sir.
So I am expecting you, at least you have watched some lecture, not all lectures, but at least you have watched some lecture.
Yes, sir.
So that thing I will expect from your side.
Yes.
Okay. So have you started working on your assignments, respective assignments?
Yes, sir.
Yes, sir. Same.
Okay. How is it? How is it?
Yeah, it's
Very
going
simple.
good.
Very simple.
Yes, sir. Yes, sir.
Okay.
Not that much simple, sir.
Okay.
Some complicated.
Okay. It depends. It depends on perspective, right? If someone is not from mathematics department, they really feel difficulty on those topics as well.
Correct. Yes.
Yes, sir. I'm from
Okay,
commerce.
if someone has already done those topic in their BSc or on their BTech or on their 12th or 11th standard, so they feel really easy for those topic. Interesting, nice.
Yes, sir.
Okay, okay. Before starting the class, I will let you know some rules. See, since in this class, most probably the strength is around 136, right? And most probably once the class will start, more person will join the session. So the class strength will be around 150 to 170. So my humble request from to you that please don't rush on the comment box and mute yourself. If you have some doubt, you can unmute yourself and then let me know. But if you don't have any doubt, please in the during the class, please unmute yourself. Okay, sorry, mute yourself so that the class will go smoothly. Okay. Otherwise,
Yes,
what
sir.
happens is someone is unmuted themselves and some Dhania wala bhaiya is shouting in behind that person. Okay, so that kind of thing I don't want.
Okay,
Okay,
sir. Yes, sir.
any general concern that you have? If you have, you can ask.
Sir, I have a
Yeah,
one concern. Yeah, have.
yeah.
See, I'm a government employee and 7 to 9 a.m. means very difficult for me to attend this class. Can you help me?
Yeah, this class is recorded. The thing is, this schedule that 7 to 9. This is only for one class. That Friday session will be happen on 7 to 9 because all the sessions are already scheduled. So one thing that you can do, these sessions all are recorded and they are available on YouTube. You can just watch on YouTube. See, because there are so many students. See, the thing is, there are 4 courses, right? And each courses has schedule on their time. That's the thing.
We just shift little bit from 6:30 to 8:30. That will suffice
Okay.
if possible.
Okay. Okay, I'll try, but I don't think so that will be possible because you are not the only one student. There are many students in this session, in this class, and the thing is, 4 to 5 session we have to schedule accordingly, right? So most
Okay,
probably
sir.
the first session will be happen from 7 to 9 only. I don't think so. They
Okay,
will.
sir.
It's not up to me. It's up to the authorities that they are scheduling. I am just taking the class. That's it.
Okay, please convey my concerns.
Yeah, even I don't
Yes, sir.
want to take classes from 7 to 9. It's really difficult for me to wake up early in the morning and then take the class. Okay,
Okay, sir.
but yeah, that the way it is, I have to do. That's it. This is the way.
Okay,
Okay,
sir.
no issue. If you really feel difficulty, you can just take this session like after the class as well. It's not mandatory, like you have to attend the session. No.
No, it is not
Okay.
mandatory, but it is very helpful to clear my doubts. I have small doubts.
Yeah. Because in each week there will be 3 sessions, 3 instructor sessions. So you can ask any
Okay.
of them. Okay.
Right, sir.
Anywhere.
Okay. Thank you
Like
very much, sir. Right, sir.
rest 2 session will be in the evening only. 8 after 8 only. So no issue. Okay. Which YouTube channel will the recording be uploaded? IITM BS program itself. Sir, where we can access all recording of the love session. Okay. You can you can access. You just search IITM BS program on YouTube. You will find the recordings. Okay. Or most probably wherever you got this Zoom link, there will be one YouTube link as well. Okay.
Yes, sir.
Okay. So most probably I will try to cover all those things. And this is not like if session is scheduled from 7 to 9, it will go from 7 to 9. There will be possibility the session duration will be more than 2.5 hours or 3 hours. There is a possibility according to the topics that we are covering, according to your understanding speed. Okay. I will try to cover all those things, and I will also try to take all of your doubts that you have. Okay, no matter like however they are small, how silly the doubt is, no, it doesn't matter. Okay, so I will
Yes.
try to take all of your doubts. Yes, Pamit. Okay, so one of you are saying they have some doubts on some numbers. So can you please let me know what is the doubt, so that
Yes, sir.
I
Yes, sir.
can
Yes, sir.
just
Yes, sir. Yes, sir.
quickly take the
Now,
doubt and
yes. Doubt number 1. 0 is a
Okay.
natural number. How? I am not able to understand this thing. How the natural
Okay.
number start from the 0. This should be start from the 1.
Okay.
And second doubt.
Yes.
Definition of rational number. You defined in the class, in the recorded lecture, it was defined that it is in the form of p by q, where q is not 0. That doesn't mean, but I think rational numbers is the p by q, but q is not 0. This is the definition that I read during my studentship. Now I'm not no more student. I am a government servant. I'm 50 years old.
Okay, no issue. Natural number, you are saying how?
It start from 0.
How it start from 0, right?
Yes, sir.
Okay. And another doubt is on rational number.
Yes, rational number should be p by q, where q is not 0.
P by q.
Where q is not 0.
Q is not equal to 0, and
Right,
P
sir.
and Q are coming from Z.
Yes.
Okay. Just a minute. I have. So this is the definition of rational number. There is no such concern, right? If any number can be represented as, in the form of p by q, where p and q are coming from your integers and q is not equal to 0, in that case that number is known as rational number. This is the definition of rational number. What is the concern here?
Yes. The concern is that in the recorded lecture, this is not mentioned that q is not 0.
Okay, it's okay. Just remember this thing. There is a possibility that they missed that thing. But q has to be equal to 0. Q is not equal to 0. Okay, in that case, because otherwise this fraction will not define at any case. Okay. And see, in the natural number case, why we are starting from 0? Because the thing, see, whenever we will define something, it's not mandatory that we will define according to books, according to something, right? If we have to define something, it's not mandatory that we have to define from our some specific book. No, right? In books, basically what we have learned the natural number is start from 1, 2, 3, 4. All the counting number that we are including that, right? All the counting number are basically natural number.
Yes,
They
sir.
start from 1, right? That we have learned. Basically,
Right, perfect.
in this
Yes,
in
sir.
this
Yes, sir.
in this program, why we are starting natural number from 0? Because if someone knows Python, so they know the thing that Python will count from 0, right? Not from 1.
Yes, sir. Count from 0 starting.
That is why we are starting. We are teaching you natural number is starting in this course only. It's not applicable for
Okay.
all. It depends on the
So-
teacher. It depends on the books. It depends on the perspective as well. Okay, it's not mandatory that you will start natural number from 1, 2, 3, 4, 5, all the counting number, because the Python will read the natural, like Python will start counting from 0. That is why we have to start the natural number from 0, because this is a program for data science student, right? And data data scientists need Python.
Right, sir.
I
Okay,
hope
got the
hope
mind.
this doubt
Yes,
is
yes.
clear.
Right, sir. Thank you very much.
Okay, guys, for you in calendar did show that you have class now. For me, it's showing. So how would you join, Monishwar?
Sir,
How did you
actually,
join?
in YouTube, I got a notification, sir, and I thought it would be this link, and I joined, sir. But in calendar, I'm seeing like 8:30 to 10:30 only. I'm having class. Only I got confused.
Okay, just change the time zone. From where you are joining, which time zone?
So Chennai, sir.
Chennai itself. Okay. Okay, no issue. Now you have joined, no?
Yes,
Okay,
sir.
so shall we start the sets?
Yes,
Okay.
sir. You can.
Before delaying the session, let's start with sets. Okay.
Yes, sir.
So how many of you are aware from this sets?
Yes, sir, I am.
Yes. So what is the definition of sets?
Collection of
Collection of
well-defined
data.
elements.
Okay.
A
Let's see.
collection of the all
Okay.
items.
Okay, so I will take all the definition, whatever you are saying. Okay, so someone are saying collection of
Items in a
Well-defined,
well-defined manner.
well-defined,
well-defined item.
elements. Items, yeah.
Oh, whatever it is, elements, items. Okay, elements or items, whatever you want to say. Okay, any other definition? Universally accepted items. Okay, one new words. Universally accepted item. Collection of universally accepted items. Okay, any other definition? Yes. This is for data science student. Any other definition?
Collection of items of different data types.
Different data types, that you can say, yes. Collection of items of different data types. Okay, different data types. Any other?
Sir, it is
No?
a collection of different well-defined items.
Okay, different well-defined. Yeah, here you can say, here you can say different well-defined.
Yes, sir.
Yes. Yes, someone.
Hello.
Yes.
Good morning, sir. I
Good
have a
morning.
doubt. Like,
Yes.
we are going like summary of lecture 1, then activity question, or we are just taking doubt by doubt.
No. See, the thing is here, most of the students are not from mathematics background. So this is kind of summary, but it's kind of proper session. Okay, proper session of week 1. Okay. Proper session, it means that I will cover all the basic things. I will cover all the small doubts. I will cover all the topics from your week 1. Okay.
I'm just
Okay.
asking, like, we are taking class 1, then class 1 study, and the doubts of class 1, or like doubt by doubt. Like I have doubt, then anyone has doubt, like that.
No. The thing is, it's not doubt session. First of all, it's a summary session. Summary session is like I will cover each and each topic. Okay, it's not doubt session. But yeah, if you have some doubt, you can ask.
Okay.
It's not like I have some doubt, and since it's not a doubt session, so I cannot ask the question from this session in this session. No. Okay. If you have some doubt, you can ask. No issue.
Sir, may I ask a doubt regarding a question? Like
Yeah.
a part
Regarding a question, regarding a topic, regarding whatever you want. But I am expecting from your side that you will thus topic is see, since here topic is this sets topics is now going on, and you are asking from function. Please do not do like that, so that it will be helpful for me as well, right? If some topics is running now, so you can ask doubt related to those topics. Okay. Or if you have some doubts on another topic, you can ask in the end of the class or beginning of the class. Okay.
Yes, sir. Understood.
Okay. Now I'll start.
Yeah, start. Sir.
Okay.
Yeah.
Okay. So many of you are saying, sir, collection, we need collection. And somewhere here we need this well-definedness, right? Sir, can we go with the topic and take doubt at the end of the class? Yes, Ankit, we can. Okay. So first of all, let's discuss about what is this collection, and then we will say we will see what is this well-definedness means, and then we will see how correct this definition is. Okay. So why we need this collection? First of all, why we need this collection? Anyone?
Sir,
To
to study a group of items in a very precise way.
Okay. In easy way, someone will say?
To know the quantity of things we have, or like study them.
Sir, to collect similar type of items in one place.
Yeah, that you can see. Okay.
And
Any
sir,
other?
Sir, to analyze a collection of items very easily because of this set.
Okay, some vague definitions are coming. Okay, let's see with the small example. Suppose this is Mohan. Okay, this person is Mohan. Okay, don't judge me by my drawings. Okay, my drawings is very bad. So this is Mohan, and this person went to a medical shop. Okay, suppose here is the medical shop. This is a medical shop, and here one person is standing. Okay, this is one person which is standing. He went to the medical shop. This is medical shop, and he asked him, please give me an paracetamol. Okay, please give me a paracetamol. So if you will closely observe to this person, he wants paracetamol. Okay, paracetamol. Okay, and if you will closely observe to this person, what he will do? He will just go to some specific place in this medical shop, and he will just choose a specific box, and he will put a medicine. Okay, he will take a medicine and give it to you, right? That thing you have seen whenever you will go to the medical shop and ask some medicine, right?
Yes, sir.
Yes, sir.
Right.
Yes, sir.
So what he will do, he just go to some specific place and choose some specific box and take medicine and give it to you, right? So what see how this person know this is the paracetamol medicine? First of all, one question is how this person know, right? How he knows about this, right? So
Yes, sir.
what is the answer? What is the answer for this question? Initially, when this person will get some bunch of medicine, what he has done, he had specify all the medicine, right? Suppose in this place he has collected all the paracetamol medicine. In this box he has collected all the different medicine. Okay, and various kind of medicine he has collected according to their properties, according to their names. Okay,
Yes,
right?
sir.
Because
Right?
similar items are stored in the same place.
Yes. So why we need this collection? Why we need this collection? Because whenever in future, whenever we will need that kind of collection, we can directly go to that particular place. We can go to that particular collection and take some elements from the collection or take some items from that collection, and we will use according to my need. Right?
Yes, sir.
Right? Now here we understood that yes, why we need this collection, right? But what kind of collection it has to be? This is one doubt, right? There is a possibility that in that box itself, he will put some Disprin, he will put some Eno kind of thing, right?
Yes, sir.
Right? So first of all, that collection has to be well defined. Okay, what do you mean by well defined? Okay, let's take another example and then we will try to understand what we need from well defined. Okay, so you understood now? If I am putting in paracetamol in this box, so any other medicine has not to be there in this box, right?
Yes, sir.
Right? Then only I will say, yeah,
But
this
sir-
collection is well defined. Yes.
Collection, it is a set is the collection of well-defined items. It doesn't mean that is the similar type of items.
No,
The collection
thing is,
includes
set
paracetamol.
see. The set.
Yeah.
I am not explaining the definition of set right now. I am explaining why we
Right.
need this collection and what
Okay.
this well defined means. Okay. Then here I am not saying this definition are correct. Okay. I will let you know what is the wrong thing inside this definition. Okay. There is a small mistake that you guys have done in this definition. I will correct that definition, but I am just explaining why we need collection here and what this well-definedness means. Okay.
Okay.
Right, sir.
Okay. Now, suppose if I will ask someone in this class, please let me know your favorite cricketers. Okay. Please let me
Kohli.
know your favorite cricketers.
Kohli, Dhoni.
Okay. One by one. Okay. Who is speaking?
Virat
Tell me your name.
Kohli. Chirag, sir.
Tell me your name first.
Chirag, sir.
Okay.
Chirag.
Chirag. CH I am taking from Chirag.
Yes, sir.
Okay.
Yes.
Chirag is saying, tell me your favorite cricketer's name.
Sir, Kohli.
Okay. Kohli. Okay.
Dhoni.
Okay.
Dhoni.
Just oh, only Chirag. Only Chirag will say. Okay.
Okay, sir.
Kohli. Then
Sir,
Dhoni.
Kohli, Dhoni, Pujara.
Okay. Pujara. I think he has watched lecture and he is taking the name from
Yes,
there.
sir. Mine is Kohli and Dhoni only. So
Okay.
I
No
don't
issue. No issue. Okay. Any other person? Please
Ravi,
tell
sir,
your
Rohit
name and
Sharma.
then. Sorry.
Ravi.
What's your name first?
Ravi.
Ravi is saying
Rohit Sharma, sir.
Rohit Sharma and
Ishan Kishan, sir.
Ishan Kishan and
AB de Villiers.
ABD. Okay. One by one. Any other person? This is
Sir,
Ravi.
may I?
Yes. What's your name?
Yes.
Yeah, Vignesh this side, sir.
Sorry, Vignesh. Okay.
Yeah.
Vignesh.
Yeah, so Adam Gilchrist,
Okay. Adam Gilchrist. Then AD.
Shane,
I'm writing it.
yeah,
Okay.
Shane Warne,
Shane Warne.
yeah, then Travis Head.
Travis said. Okay. All the foreigners. Okay. No issue. Okay. That's it. So if you will closely observe to this collection, that what is the discrepancy in this collection here? The thing is, in this collection, if we will closely observe, this collection is changed if we will if I am going to ask from each another person, right? What was my initial question? My initial question was, who are your favorite cricketers? Okay, that was my initial question, right? That question was same for each and everyone. Right?
Yes, sir.
That question was same for each and everyone. But whatever collection I am rating here, that collection is changing if I am asking from different person. Right? This collection, whatever I have taken here, if I am asking from different person, this collection is changing according
Yes,
to
sir.
their like and whatever it is, right? So I don't need this kind of thing, right? Suppose I need paracetamol thing, and I found some discipline medicine inside that paracetamol box, right? That thing I don't want.
Yes.
Yes, sir.
So for that, this well-defined words come into the picture. Okay, this well-defined words come into the picture, and it tell me that whatever collection I am taking, that collection has to be well-defined. What does it mean? If I will ask about this collection, about that collection, okay, for any person, to any person who is alive, okay, that collection will be same for from each and every person. Okay, that collection has to be same for each and everyone. Okay, each and every person. Okay, this observation I hope you have yes, Asu,
Yes, sir.
you can get it. Okay, this is the observation, right?
Yep. Yes.
Right? If I need some collection, that collection has to be well defined. What does it mean? It means that if I will ask any other person, no matter where he is, if I will ask some person who is in the Mars, that collection should be same for for that person only, that person as well, right? So in that case, if I will ask you another question, just give me a list. Give me a list of cricketers who was captain of Indian cricket team. Now, if I will ask you this list, about this list, does this list will be changed?
No.
No, sir.
No, right? No matter if I will ask from an American guy, if I will ask an Russian guy, if I will ask an Martian guy, that collection will be same for each and everyone, right?
Yes, sir.
Perfect, sir. Yes, yes.
Right? So that kind of collection is known as well-defined collection. Okay, one more thing. Suppose someone will say, sir, Rohit Sharma is a captain, and as well as Rohit Sharma is captain, right? Here two same items are there. So I don't need this kind of thing as well.
Yes, sir.
Right? So for representing one particular thing, I need only one thing. Okay? So this kind of repetition has not to be there.
Yes.
I don't want this repetition. Okay? So please mute yourself. So what I want, collection has to be same for each and everyone. Okay? And that whatever elements are there inside that collection, whatever members are there inside that collection should not be repeated. Okay?
Yes, sir.
Just like in your family, if I will ask, sir, just tell me who are, just a minute. Okay, just tell me about Vignesh families. Okay, Vignesh family. So Vignesh will not write in my family I have suppose his father name is what to say, Mohan. So he will say Mohan is my father, also Mohan is my father. He will not say like that, right? He will just introduce one by one. Mohan is my father, suppose the Seema is my mother. That kind of thing will happen, right? Or he will not going to say, sir, Rohit is my brother, Rohit is my brother. No, right?
Yes.
Yes, sir.
Yes, sir.
So you understood what does this well-defined means? Why we are including this well-defined words?
Yes.
Yes, sir.
Now tell me, I need well-defined collection or I need collection of well-defined item?
Collection of well-defined items.
What I need? I am again asking here what what I have discussed up to this. We have discussed whatever collection I am taking, that collection has to be satisfy some properties, right? That collection. My voice is not coming.
Yes.
No, it
Yes,
is coming.
sir, coming.
Coming, sir, coming.
Very clear.
You're audible.
It's coming. Not
Okay.
not
So
problem.
what I have told you before, I told you that collection has to be satisfied two things. One thing is that collection has to be same for each and everyone, and any element which are inside the collection that will be that should not be repeated, right?
Unique elements.
Yes, unique elements has to be inside the collection, right? So what I am saying, see, question is, I need well-defined collection or I need collection of well-defined object.
Well-defined collection.
Collection of well-defined items.
Object. Okay. So if someone are saying I need this, so please write Y. If someone are saying this is the correct definition, please write N. Which one is the correct?
Defined collections.
Both. Okay.
What is the difference between them, sir?
I will let you know now. I will let you know. Sir, should I buy the book given in the course section? If you have something in course section, just go to the printout shop and then take the printout. Don't need to waste your money.
I think he's on to
Your
say
voice
that,
is not coming. Your voice is not coming.
for
Your voice is not coming. Just write whatever doubt you have in your chat box. Okay. Okay. Let's discuss. Well-defined collection means what? Whatever we have discussed here. We need collection which is well-defined. Well-defined means I already told you that collection has to be same, first of all, and the elements will not be repeated. Okay. Now, what does this means? Well-defined object. It means that whatever you are taking inside this collection, that particular thing has to be well-defined. Suppose I am taking paracetamol in this box. So should I say that paracetamol is not well-defined? What does this mean? It means that there is no such value of that paracetamol. No, right? If something is in exist, that is already well-defined, right?
Yes, sir.
That is already defined. That is why that particular thing is exist, right?
Yes.
Yes, sir.
Right. So there is no such mean of this well-defined object. Okay. This is the confusion. Most of the person are saying, sir, collection of well-defined object. But the thing is, what do you mean by this well-defined object? If something is there in the real life, it means that is well-defined.
Yes.
Understood?
Yes,
so what
sir.
we need this collection that has to be well-defined.
Sir,
Yes.
sir, as you said, well-defined objects are that something which everyone defines the same, right?
Well-defined
So
collection.
there was an activity question in which there was a set.
Okay.
It consisted of balls and the name Dhoni. So everyone might not define every ball is the same. Some might say tennis ball, some say rubber ball, etc. So can we say it was a well-defined?
No, the collection is changing, right? Can you take the screenshot of that particular question and paste here so that I will take that and then I'll let you know.
Okay, sir.
Okay, just
Sir,
take the
I have
screenshot
one
of that question. Yes.
Sir, can I ask my question?
Yes, sir.
Collection of deities
Datas, yes. Datas, right?
No, not datas, not datas.
Okay.
Goddess.
Oh.
God and goddess. Collection of God and
God and
goddess.
God.
Is the
Okay.
yes. Is the well defined? Is the set or not?
No.
It is not the well defined.
Yes. How will you make that collection, first of all? Yes, Prabal.
I'm just
Yes, Prabal. How will you make that collection? See, for each and every person, that particular collection will be different, right? So if you will ask some Muslim person, they will say, yeah, Allah is my God. If you will ask from Hindus, they will give you plenty of names. Okay. If you will ask some Christian person, that collection will be different. So how will you define that collection?
it is not a collection. It is not a set.
And yeah, until and unless you will say God is same for each and everyone. Okay.
Yes.
Okay.
Okay.
So
Yes, Prabal.
suppose I
Yes.
modified my collection of Hindu god and goddess.
Yeah, that then you will say, yeah, it's a collection.
I don't think
Because
that will be
whatever it
collection.
is,
There-
yes, whatever
That-
it is,
so many-
which are mentioned. Yes.
Yeah, I think the collection of universally accepted items. This is the perfect definition. Well defined is wise. Yeah.
See, universally accepted items means what? First of all,
Means everyone paracetamol. Everybody will agree that this is a
yes.
paracetamol.
Give
And
you
the
any
label will be there. And
yes. See, what was your question? First of all, think about it. Your question was just give me the collection of Hindu gods, right? So whatever gods are mentioned in your Ved and Puran, that collection will be the set, because that collection will not be going to be changed. It doesn't matter if someone is coming to me and he is saying, I don't believe on God, so that will be not my collection.
okay,
Right? It doesn't mean.
right.
It doesn't mean.
Right, sir. Okay. Yes, yes.
Sir, in this question, the elements are well defined. No, see, if something is exists now, it means that that is well defined. Doesn't mean it's suppose if I will ask you, if I will I will talk about complex number. Though they will say, yeah, complex is something which is like we are image like that are imaginary number kind of thing. No, but whatever it is, they are. Though they are imaginary number, but we have given some representation to those number, right? It means that they are in exist. We are using those number.
Yes.
Yes, sir, but it is a set or not, sir?
It is a set. Could you
Okay,
please
sir.
explain the difference between sets and collection? I have explained, no? What is the set? The set is collection, well-defined collection of objects. Okay, well-defined collection of data, well-defined collection of items. Okay, and collection is just a collection. See, here we have discussed this. This is also a collection. This is also a collection. This is also a collection, but this is not well defined.
Hi, sir.
Okay,
Am
sir.
I audible?
Yes.
Sir, I have a question regarding relations. May I ask that?
You will ask, but firstly, I have to start the relation. No?
Okay, sir.
I told you before, like if some topics is going on, please ask related to that
Okay,
topic
sir. I'm
only.
sorry, I joined late. Sorry, sir.
It's okay. It's okay.
Sir, here I have this thing doubt because in the previous question that when we are asking about the favorite cricketers, it was a general kind of a question. Whereas
Yes.
in the second thing, your question was well defined because you are asking about the list of captains. So the
Yes.
answer is changing in this question, then, right? So again, the whole definition is changing based on the question or the situation.
Yeah. The situation and the question based on the question as well. What kind of question I am asking?
Yeah.
Actually, that question is defining the definition. Further, we will see when we will go how we will represent the set, how we can define a set. Then we will easily see that particular question that I have initially asked, that particular question itself is defining the definition of that particular case set.
Yeah.
Okay. Further, we will see that kind of thing. Whenever we will
Sir.
discuss about roster form and then comprehension form, then we will easily see that particular question, whatever I am asking, that particular question itself is defining the set.
Yes. Okay.
Yes.
Thank you.
Sir, means basically we can say that every set is a collection, but every collection is not a set.
Yes. Every collection is not the set, but every set is a collection. See, why? Because in the definition of the set, we are saying, what is the definition of set? A well-defined collection of object, a well-defined collection of data, a well-defined collection of items, or a well-defined collection of element is known as set. Okay.
Yes,
Any doubts up to this? Shall I move
Sir,
forward?
sir,
Yes,
sir,
sir, you
sir.
Yes.
can.
Sir, I have posted a question in the chat from.
Where? Just take a screenshot. It's difficult for me to understand this. Anyone is
Yes,
understanding what is it?
and the question I was talking about, the screenshot is there in the chat.
Yes, sir. It is above the screenshot. There is a screenshot in the question.
Where is it?
Suppose you sir scroll up, then suppose X type is
Kalyani
the
has
question.
sent. No, right? This is not. Can you please send me once more? It's difficult for me to find. Okay, okay, just send it once again. And I am moving forward. Just send it once. Where I
Sir,
did not get it.
sent
That's
a
it.
question, sir. Sir, I have sent it now only.
Yeah, Chirag, I got it. Okay, let me share this question for everyone. Just a minute. Okay. Okay, just a minute, okay. Okay, is this question is visual to all? This 3 pi tiger ball question, right?
Yes, sir.
It is
Yes,
visible.
sir.
Yes, sir. Yes, sir.
Yes, so
Yeah.
what is the doubt here?
So the doubt is, as I was saying, as the ball is in the set, so everyone might not define the exact ball, like it might be a tennis ball or might be some other kind. So is it well defined exactly?
Okay.
And the same is for the Dhoni. Dhoni might be anyone's name. Is it for a specific person?
See here, if someone is mentioned Dhoni, it means that some Dhoni is there. It's just a name, okay? Otherwise, you will say, sir, tiger is there. It means that, yeah, that particular tiger name is what? The tiger belongs to some other person, right?
Yeah.
No. So the thing is, here, whatever you are saying, your doubt is correct. But the thing is, here we have mentioned these names, right? Tiger, balls, and Dhoni. Okay, this is itself a well-defined element, or this is itself an element, not well-defined element. This is itself an element. Not like here you can mention the tennis ball, here you can mention the like cricket ball kind of thing. Okay, this ball is itself an element. It's just like if I will make a collection like this. Suppose this is my name, Arpit Mohan kind of thing. Okay, I did not specify who Arpit is. Who is this Arpit? Who is this Mohan? Right? It does not mean that this is not a set.
Yes, sir, you are right.
Because
so
this is an element of that particular thing, and this particular thing itself is a well-defined thing. Okay, this particular
sir.
thing itself exists. No matter because I am representing this thing by each and by elements, right? I am not saying that I am giving you the definition, and according to that definition, I am getting this thing, right? So I specify all the elements here, right? Because in this
Yes,
set,
sir.
these are the elements inside the this particular collection.
Yes, sir. In your example, sir, a question can be asked to people that give a set of names or something. But in this question, these are random objects. So what
Yes.
could be the question form? So if there is
So,
a question form, there will be definition by people. So it will be called well defined.
Yes. So the thing is here, this set is representing its what element they are already. See, just wait for 2 to 3 minutes. I will let you know what is the like how we will define some kind of sets. Okay, then you will understand what is it basically. Okay,
Sir, so
just,
sir, in this question was a point. This option number 1 was the answer.
Just a minute. Just wait for 2 to 3 minutes. I'm
Not a
saying no.
set.
I'm just saying. Just wait for 2 to 3 minutes. Just wait for 2 to 3 minutes. You will let you know what is it basically.
Okay, sir.
Okay. Let me discuss how many ways are there for representing a set. Okay. Let me discuss about it first. You will understand. It is a little bit confusing. Okay, Shekhar. Just wait for a second. Okay, just give me a minute.
Is that a set?
So I'm saying no. Just yeah, for me it's a set. Currently it's a set. Okay, but how it's a set, I will let you. Just a minute. Okay. I know who is studying this thing first time. They have lots and lots of doubt. I can understand because when I was studying this thing in my first time, I was that kind of confused person.
Excuse me, sir.
Yes.
So, just one doubt. So, can you give me an example of something that is not a well-defined object, just to get some more clarity?
Well-defined object?
No. Something that is not a well-defined object.
Something that is not a well-defined object. How can I?
Means set. Yeah, so just because like when we refer to the definition, when we say that it is a collection of well-defined objects.
If I am telling you something, whatever thing I will tell you, that particular thing is itself a well-defined. That is why I am telling you, no?
Right.
Now, if I will tell you 1 by 0, now just show me what is it.
That's
nothing.
What is
if you can you say this thing is inside something?
No, sir. But
this is not defined.
Correct, sir. So, but in context to something very so maybe a fictional character is well defined because it is written in a book or not? Fine,
yes,
because
that is well defined because it is written somewhere else,
okay.
right? Somewhere.
Got it. That's So I got my point. Thank you so much.
See, whatever thing, no matter they are fictional or something. If I will ask you, just give me a collection of all the Marvel characters.
Right.
Okay, they are fictional, but it does not mean that they are not a set.
Yes.
They will not form a set. Okay.
Yes, sir. Thank you so much.
Okay, let's move forward. So we will see how many ways we have for representing something a set. Okay. So suppose in your family, so in Rohan's family, okay, Rohan is there, his mother is there, his father is there, and his sister is there, sister 1 and sister 2. Srivastav Kumar, why do you need for remote control? Please don't send request and don't interrupt inside the class, okay? Sister 1 and sister 2. And this family is known as, suppose, what to say, Gupta's family. Okay. Or Rohan Gupta family. Okay. And this Rohan went to a marriage, and suppose this Rohan has a beautiful girlfriend. Though this is not look like a beautiful girl, but yeah, this Rohan has a beautiful girlfriend, and Rohan wants to introduce his family to this girl. Okay, Rohan wants to introduce this family to this girl. How many ways that Rohan have for introducing this family to this girl? The first way is Rohan come to this girl and Rohan will say, see, this is my family, right? First way is he will directly say, this is my family. Right? Another way is he will just go to this girl and he will say, this is my mother, this is my father, this is my sister, this is my sister 2, sister 1, sister 2, and this is me. Right? There are two ways.
Yes, sir.
Either he will introduce by person of person. He can introduce by person. Right? He will introduce by person, like this. She is my mother, he is my father, she is my sister 1, she is my sister 2, and this is me. And he will directly say, this is my family. Right? There are two ways. In that, in both of the case, that set will be same, right? That collection will be same. So what I got two ways of representing any kind of set. First way is either I will represent by elements. Elements mean I will write each and every element of that particular set, or I will say that particular set will follow some kind of rule. That particular set will follow, because it's a well-defined collection, so that collection will follow some certain rule. Just like in the initial question, whatever I have asked before, that I am asking, give me a list of captain give me a list of cricketers who was a captain of Indian cricket team. So this particular collection is follow this rule, because what are the elements inside, what are the member will be inside this collection. That particular element has to be the captain of, in their part, has to be the captain of Indian cricket team. Right? So it means that all the elements inside this collection are following some specific rule. Right? Similarly, in this example, if he is saying this is my family, it means that each and every member of those collection has to be their family only. Right? Either she is his mother, he is his father, she is his sister 1, sister 2, whatever it is. But it has to be that particular belongs to be in this family, right? The Rohan's family, right? There is no such way.
Yes,
right?
sir.
So we have two ways. The first one is either we will introduce by some rule, and we will introduce by person. Okay. So this form where we will discuss about the rule is known as comprehension form. Okay. Just a minute.
Yes.
Comprehension form, and this form where we are introducing person by person is known as roster form, and this is also known as set builder form.
Roster and
okay,
tabular
understood?
method.
Sorry?
Roster and tabular.
Yeah, that you can say. But what is the point here? So if I have to represent some set, I have two ways. Either I will represent by whatever rule that particular set is following, or I will introduce by person, right? So in the previous example, where is it? In this example, here we have discussed about this set by its element, right? I am not saying there is some definition which is following this set, right? I am just defining by its element. So now tell me whether this particular thing is a set or not.
It is a set.
It is a
sir.
set.
It is a set by, because I am introducing by element, right?
Yes, sir.
Right?
Yes,
I am
sir.
introducing one by one.
Yes, sir.
Okay. So now
Yes.
you can see which one is the correct option. Okay, I hope
Could
you
you repeat
understood.
what you just said about this set, about this particular problem? Could you please repeat it once?
That example.
That person by person thing? No, not
This
the
one.
example. Yeah, this one.
So here, as you can see, this X, whatever this X is saying, if this X has to be represent his family, what he will show? Inside my family, 3 is there, pi is there, tiger is there, ball is there, minus 40 is there, and Dhoni is there. Okay, it's not saying here there is no such thing. Like if I will ask some person who is lying inside the Mars, and I will take this particular thing to this, I will show this particular thing to that person, and I will say whether what do you think about this particular thing. So what he will say? Yeah, this is a set, this is a collection, because this particular thing, this particular collection will not going to change for anyone, right? Because I am representing each and every person here. Right? If I will say, sir, I will take beta 1, and then I will say I will take Rohit Sharma, and then I am taking, see, this is a beta 1, okay, just an representation. And now I am taking Rohit Sharma. Now I am taking Vignesh here. Okay, now I am taking myself, Arpit. Now I am taking Sun. But I am representing each and every element here, right? Right? I am representing, I am explaining about each and every element here. I am not saying this particular thing is there. No, I am representing each and every element here. So understood? Here I am defining my set by its element.
Sir, but if we say like that, then every collection or any collection of items, whether it is a well-defined collection or not, it'll be a set. I mean, there will be no.
It depends. It depends. It depends what kind of question you are asking. It depends what kind of question you are asking. Okay. If you will say, sir, here, where is the initial answer? The question here. If you will say, if you will talk about this particular thing only, and if you will ask me, this is a set or not? Yes, this is a set. But if you will ask me that particular question, that tell me about your favorite cricketer, then this is not a set. Why? Because for each and every person, this particular set will be this particular collection will be different. But if you will ask about this particular collection, whether this is a set or not, yes, this is a set, because here I am representing each and everything by its element, not by some previous question. Okay, you are getting my point or not? If you are defining something by its element, okay, it means that you are telling me these are the elements are there inside my set, then inside my collection, so that then it's a set. Okay.
So sir, for a set to be called a set, it is not necessary that it has to be called by some name. For example, you gave the example of this captains of Indian cricket team.
Yes, yes.
Then it is very well defined collection.
Yes.
That only those captains will be there in the set, and for everybody the answer is going to be the same. And similarly for Rohit's family, because it is Rohit's family, all the people in the Rohit's family, they will be same, and everyone will give the same answer.
Yes.
About Rohit's family. But sir,
yes,
but when we see this question, how to call
see, the thing is,
by what name can we call this collection?
See, the thing is,
necessary. Yeah.
Just listen to me carefully. The thing is, currently I am not able to define a rule for that particular question. Okay, I am not able to define a rule. It does not mean that that rule is not exist for that collection. I will directly say here now, where is the question? Now I will say which activity this question? Activity 1. Suppose this is from activity 1. Yes. So I will say, just tell me the set who is in the question number 2 of activity 1 in IITM BS program mathematics 1 program. Now this set will given to me, right? Only now yes, I have defined a rule.
Sir, so that only basically does that mean?
No, sir, but we are trying to justify whether it is a set or not. So we cannot say that it is a set is given in the IITM activity this, because until we confirm that it is a set, we cannot call it a set, right, sir? So
yes, the thing is, just listen to me carefully. The thing is, sometimes what happens is I am not able to define some rule for that particular thing. It does not mean that that does not a set. Okay.
Okay, sir. Okay.
Okay, if I am not aware about that particular rule from where this is coming, that is why we are defining this two form, right? Sometimes I am able to define my set by this roster form, or sometimes I am able to define my set by comprehension form. Just like if I will give you the example, if I will tell you just this is the collection of natural number 0, 1, 2, 3, 4 and dot dot dot. What does this mean by dot dot dot? Right? I cannot define my natural number set like this, right?
Right, sir.
Right? Because here I am not able to write in each and every element in this case. So for that I will use first definition, but it does not mean that 10 is not there. It does not mean that 15 is not there inside this. Similarly, if I will give you the random data in this place, it does not mean that this is not a set. There will be some rule from where this particular thing is coming, but it does not mean that this is not defined. Okay, I don't know about that rule. The question is in this question, the question is here, since we don't have certain rule for coming from where these elements are from there, these elements are coming inside the set. So how we will say this is a set? Okay, there
So
will be
how
some
will
certain rule
identify
from
that?
where these elements are coming. Okay, but right now I don't know. But does not mean that that particular rule is not there. Yes.
Sir, how are we going to represent this particular set in roster form then?
That's what I am saying. No, that's what I am saying.
So you are saying that it is quite possible that a collection is a set, irrespective of whether we can define it in a roster form or in a comprehension form.
Yes.
Or is it necessary that a set to be called to be a set must be represented in any of the two forms?
Any of the two form, it has to be represented. But the thing is, if you are representing from one form, suppose something is there written in the roster form. Okay, so there will be some certain rule because both form are equivalent to each other. Yeah, there will be some rule for which that particular elements are coming. But currently, I don't know that rule. Okay, but there will be some rule.
The rule exists.
Yeah, the rule will be exist, but I don't know that rule. That is why I am representing by its elements, right?
Element wise. Okay.
Yes. Okay. That is why I am representing by its element. Similarly, from the comprehension thing as well, if I will ask you about this natural number thing, I cannot represent it that particular thing by in the roster form because there are infinitely many elements. How will I represent by each person by person? No, right? It's not possible, but it does not mean it cannot be represented. It cannot be written in the form of a roster form, right? Right. I am not able to represent. I am not able to write that particular thing. It does not mean that it cannot be written.
Got it.
Right? Got it?
Yes.
So both are equivalent, but the thing is sometimes I am able to write my set by roster form, or sometimes I am able to write my set by comprehension form, just like set of real numbers. Okay. Now I hope you understood.
Yes.
Okay. Okay, some notation. Okay, Prem, I will take that out. Okay, some notation are there. Okay, you understood now? You know, as something is there inside this element, suppose A, B, C, D, I am taking from here. So if I have to represent this A is inside this S or not, then how will I represent? We will represent A belongs to S, where S is a set. So here you can write if S is a set. Okay, this S is a set. Then A belongs to S, it means A is an element of S, or you can say A is a member of S. Okay, this is one thing. This is known as belongs to. Okay, if you will see A is in A belongs to S, it means that A is an element of S. It means that A is inside this set. A will be the member of this set. Okay, this is one. Remember this notation. This will be really helpful for you. Another one is this known as for all. This is a for all notation. Okay, opposite A. This is for all notation. Opposite E. This represent there exist. Okay, and one more notation that we will use further is this. This is a subset. I will explain what is subset of something. If I will write A is a subset of B, so we will A is a subset of. Okay, these are the notation that we will use in further classes or in further weeks. So please note it down. Okay. Okay, everything is clear up to this?
Yes, sir.
Okay,
Yes,
one more
sir.
general thing that I will tell you. Okay. Please make a Telegram or WhatsApp group for you guys. Okay. Why I am saying this? Because it will be really helpful for you for discussing questions and all.
Yes.
Yes, sir.
Okay, sir.
Today I'm not going to reveal my email ID. Once your qualifier will be done, I will give you my ID if I will be there. Okay, email ID.
Okay.
So if you will have some doubts, you can directly mail me regarding that particular doubt. Currently, I will not give because once the qualifier exam will, no, I will not going to join. Okay.
I'm not going to this group.
Just
Hello.
make for student only, so
I
that
have, sir, a
if you have
question.
some
Please
general
discuss it, sir.
Sorry, what question?
Sir, in the chat box I have shared.
Can you say what's your name?
Roshan Biswakarma.
Could you say send me once again?
Okay, sir, I will.
Let's move to the subset part. Okay, subset. This is easy. Nothing is there. So we will say A is a subset of a set B if and only if all the members of A are the members of B. Okay, and mathematically how we will write? We will write it as A is a subset of B if and only if for all x which are inside this A, this implies if x is inside A, this implies x is inside B for all x belongs to A. See, we have used most of the word. This is for all. It means that I am talking about each and every element which are inside A. So what does it mean? If A is inside A, or A belongs to A, or A is X is a member of A, then X has to be member of B. Okay.
Okay.
Oh, okay. And Venn, if we will talk about the Venn diagram of this, what is Venn diagram? Basically, we will use our Venn diagram by this square box. This square box is basically my universal set. Universal set means there is a big set. Okay.
Yes.
Big set. Big set. You can say big set. Okay, there is no such definition of universal set because universal set can be different for each and every person. Okay, so this is my universal set. Suppose this is a set and this particular set is that kind of thing. This is represented as set A. Okay, so this is my set A, the definition in the Venn diagram. Now, if I will say A is a subset of B, what does it mean? This is my universal set. So this is my bigger set B, and A is a subset of B means what does it mean? All the elements of A is also elements of B. It means that A will be lie somewhere here. Here you can see all the elements of A is also inside the elements of B, right?
Yes.
Right? Understood?
Yes.
Yes, sir.
Okay, who is a JE entry? Who is a JE entry? They already know this concept. This is a silly thing for them. Okay, subset you understood? Any doubt? It's easy, right? Right?
Yes, sir.
Okay, then what is? Okay, then from here you can easily see. Since
but B is not subset of A.
That you can say, it depends on B and it depends on A. Okay. So from here, what is our observation? The observation is that A is also a subset of A, right? Why? Because for all X belongs to A, this implies that this X is also belongs to A because A is same. So here you can say, now here what you can say? Every set is a subset of itself. Right? Right? Every set is a subset of itself.
Yes, sir. Yes, sir. Yes, sir.
Second thing that you can observe is phi, which is known as empty set. One more thing. This is looks like a phi. Okay, Greek word phi, but this is not a phi. Okay, this particular thing is empty set. Sometimes I used to call it as phi, but it is incorrect. This is not phi. This is empty set only. Okay, representation of empty set. This is not a phi. You cannot say this is a phi. No, this is an empty set. Phi is different thing. This is an empty set only. So this is also a subset of it because there is nothing inside this set. Nothing is there. That is why that is empty. Okay.
Okay, sir.
I am not able to listen any audio, only watching the video. Why, Ria? What happened to you? Everyone is, my voice is clear for everyone, right?
Yes,
Except
sir.
Ria?
Yes, sir.
Clear.
Clear.
Yes,
Ria,
sir.
please, Ria, please refresh yourself.
Maybe she wouldn't have connected the audio.
Yeah, there is a possibility because Zoom need permission for that. Okay, this is what observation. Now, let's move to the. Okay, now one terminology is come into the picture is cardinality of the set.
Hello.
Yes. Yes. Let S is a set.
Sir, I have one doubt.
Yes.
Sir, can you just explain that empty set thing? Like empty set, how is it a subset of A?
Okay. Empty set is mean what?
There's nothing, no element.
No element inside this.
Void.
No element inside this, right?
Yes.
Now,
sir.
in the definition of the set, what you need? I am saying if something. Yeah. See, if something is there inside A, it has to be there inside B, right? But
Yes, sir.
for that, I need something inside A.
Yes, sir.
Right? But if I don't have anything inside A, I don't need to check this.
Yes, sir.
Right?
Yes,
If
sir.
I don't have anything inside this particular A, I don't need to go by this. This is saying if this happen, then this happen. If this is not
Yes, sir.
happen, I don't need to check this. automatically this will be proved.
Okay, sir.
Okay, understood?
Yes.
It's just like it's just like if you have to go to the Hyderabad by a train, then you need to book a ticket, right? If you don't
Yes,
want
sir.
to go the Hyderabad, why you need to book a ticket? You don't need to check the ticket itself, right?
Yes, sir.
Okay. So yes. So this empty set will automatically become a subset of each and every set. So let S is a set, then the cardinality of a set
What is
is
this cardinality?
Yeah, that's what I am explaining, no? Is represented by this representation, or some are represented by this, or some are represented by this, and is a number of element inside S. Okay, so just count how many elements are there inside S. That will become a cardinality of S. Okay, easy.
Yes, sir.
Okay, this is the representation.
Yes, sir.
So there is a possibility that this S have infinitely many elements. Then we will say the cardinality of S is infinite. Okay, sometimes we will say countable, uncountable, that kind of thing will come into the picture. We will discuss later for that about that. Yes.
Sir, for this empty set, would you be able to give an example of a real life situation, like where
set is empty?
Why do we need it actually? In some
Okay.
question or something, if you can tell, maybe now
Okay,
or
okay, okay.
yeah.
Okay. Now itself, no. Take n. You know what is it? Natural number. Now, give me a set of element from this n, which is less than -1. Now, what will be the set?
Empty.
Nothing, right?
It will be an null set.
Yes, sir.
Understood?
Set. Yes.
So understood this cardinality was, what is it?
Okay,
Yes.
thank you, sir.
Sir, then what will be the cardinality of that set?
0. Number of element, na? 0 elements are there. So 0, simple. Okay. Okay. Understood?
Okay, sir.
Find the difference between A subset of B and A subset of B. What?
Sir,
I initially told you, please don't rush into the comment box. If you need some, please paste only some necessary things. Okay. I'm again
Sir.
warning you. Yes.
Excuse me, sir.
Yes,
Sir,
yes.
that example that you gave of that empty set, na, where n is this thing, and anything less than -1 should become. So this can be a subset of any set, or what did you mean by an empty set is a subset of every set? Like,
We have explained, no? For being a subset, what we need?
like no element should
No
be there
element.
in
Here S does not have element. It means that this empty set. This is an empty set, right?
Okay.
Now give me any kind of set. I will show you this is a subset of that set. Any kind of set. You got this set from this set, no? This N.
Yes.
You give me any set, any kind of set. Let's take Rohit Sharma and Virat Kohli.
Okay, sir.
Rohit Sharma and Virat Kohli. This is a set, right?
Yes, sir. Yes, sir.
This is a set. I am representing it by roster form.
Roster
This is
form.
a set.
Yes.
Now I will show you this empty set is a subset of this. Okay, so this is suppose A. This is my A. Now, if something is a subset of this A, suppose S, which is a subset of this A, this is phi. Okay.
Yes, sir.
Then what I need for all elements which are inside this S, for that X has to be inside this A, right? So what
Yes, sir.
I need initially elements inside A. In that case, in phi, I don't have any element. So I don't need to go by this definition. What I am saying, for that I need, suppose this S has 1, 2. Okay. Now I will
Yes, sir.
take 1 and then I will check 1 is inside here or not. And then if it has 2, then I will take that particular element, then I will check it has that element or not. Now in my empty set, no elements are there. So
Yes, sir.
what I will take? Nothing. There is nothing to take. Right?
Yes, sir. Nothing to take, but then how can you say it is a subset, sir? Because it's not there in that set, no?
It's just like, suppose it, so what is the definition basically? Implication, what I need, if X is inside A, then X has to be inside B. This kind of thing is there, right?
Yes, sir. Yes, sir.
Just see the Venn diagram. This kind of thing has to be there. This is B, this is A, right?
Yes, sir. Yes, sir.
Right? Empty set, it means what? Empty set is automatically there because it has nothing. It means there will be no such circle inside this B. Inside this bigger circle, I am not able to find any kind of circle. I am not able to draw any kind of circle. You understood what I am saying? Empty means there is nothing.
Okay, sir. And by
So why
default,
the
nothing exists in every set.
Yeah, nothing is exists in every set, no? Because for every set you can find that nothing. Here you can find that nothing.
Okay, sir.
Okay, so I will not take any element from that set and I will take a subset. Right? It just I am giving you a simple example. Suppose Rohan family, I will get back to the Rohan family, father, mother, sister 1, sister 2. This is a set of Rohan family, right?
Yes, yes, sir.
This family has to go in some marriage. Suppose his friend's marriage is there. This is a marriage hall. Now, sometimes, usually what happens is, every member will not go to the family, right? Marriage, right? Some
Yes,
of the
sir.
members will go to the family.
Yes, sir.
It means that some subset of this family
We'll go to the
suppose
marriage.
suppose Rohan and Rohan father will go to the marriage. Sometimes what happens is no one will go to the marriage,
Yes, sir.
right?
Yes,
Does not
sir.
mean that that particular subset is not there. Understood my point now?
Okay, yes, sir. Yes, sir. Okay.
Okay. So cardinality thing is done. Now let's move to the power set. Okay. So what we have discussed up to this, we have discussed subset, right? Now, suppose we have set, suppose S is a set and S is looking like this. S is equals to A, B, C. Okay, roster form. In the roster form, I am representing it. S is a set. Now I will say what is the subset of this? What are the subset of this? So initially we will say, sir, S itself a subset. Then we will say phi is a subset. Then we will take A, singleton. It means that only one elements are there. Right? These are the elements. These are the subset. Right? These are the subsets of S, right?
Yes. Yes, sir.
Right?
Yes,
Now,
sir. Yes, sir.
what we will say, I am saying just collect all the subset of A, S. This will be the possible subset.
Yes, sir.
Then AC. These are the only possible subset, right? Of S. Right?
Yes.
Right? Sir. Huh?
Yes, sir.
These are the only possible subset. Okay, one more thing. Is there anyone who has problem with English? Last time what happens is there was some student they are not comfortable with English. So who are not comfortable in English, they can ask me their doubts in Hindi itself. Okay. You are allowed to ask, no matter. But please don't ask in Tamil, Bengali, because I don't understand. I understand only Hindi and English. Okay. So both language, I am comfortable with both language. Sir, my doubt is activity. Yes. Yes, tell me what happened. Otherwise, I will move further. Okay, understood up to this. What I have done, I have collected all the subsets of this S, and what I have seen is this is itself a set, right? And what we will say, this is a set of all possible subsets of S, right? Right? What I have done, I have initially I have a set. I have collected all the possible subset of that particular set, right? And what I have seen, this is itself a set. See, I have allowed to explain in Hindi and English both. But if someone has a specific doubt in Hindi, then only I will say, because most of the population here from Tamil Nadu itself, they don't understand Hindi properly. So I cannot use English kind of thing here. Okay.
Sir,
Okay.
one time read the chats. I will is some problems to make.
What's your name? 1, 2, 3, 4.
Vinay.
Amrapal. Amrapal, find the difference between A is a subset of B and A is a subset of B. See, Amrapal, the thing is, this is just a notation, okay? Some writers will write the first notation, some writer will write the second notation, okay? It's a really, what to say? We don't have that kind of answer for that question, because like different books use different notation, and according to the their property. Someone will use the second notation as proper subset. Someone will use the different second notation as subset only. So it depends on the writer. So I'm not able to give the answer for that question. That is why I ignored that question. And I don't want to go inside that question, because this is a different kind of discussion. It will take around 1 to 2 hours, because other person will have other doubts, different doubts. Okay, that is why I'm not taking that out. Sir, can you give another example of power set? No, we will give now. We have lots of examples. Suppose you have a set S. Power set, I am not explaining power set. Right now, what I have done, I am saying, suppose I have a set S. Okay, I have given this 3 element inside this set S. No matter what are the elements are there. But the thing is, I can make a collection of all the possible subset of this set S, right? Right?
Yes, sir.
Right? So that collection will not change for anyone, first of all. What I am saying, collection of all the possible subset of S. So what are the possible subset will be there, that collection will not be changed for anyone, means that will form a set. Right?
Yes, sir.
Collection of all the possible subset of some set S will form a set. That set is known as power set.
But it will include the set itself, right?
Yes, yes. Okay. Don't ask paradox thing here. Otherwise, someone will say, sir, take a collection of all the set of sets. Okay. Known as Ruther's paradox, I guess. Something like that. But we will not discuss that, because it will take lots of time. I have to give my lots of energy to explain why it's not a set. Okay. So I am not going with. It's not necessary for you as well. Ruther's paradox, I guess. Yes. So understood what is power set basically? So power set is a collection of all the power set of S. Is a collection of all the possible subset of S. Okay. Now let's discuss about the cardinality. If cardinality of S is n, okay, cardinality of S means number of elements inside the S is n, then what will be the cardinality of power set? See, power set of S is represented by PS. So what will be the cardinality of power set of S?
2 to the
Will be
power
2
PS.
raised to the power n. Okay. This is just what to say. And just formula you can say, otherwise I will explain how this formula will come. Suppose in your set you have n element, or we will say 3 elements are there, A, B, C. Okay. Now if I will form a subset A from this set, so how many possibilities this A will have? Either this A will be inside the set or outside the set, right? Right?
Yes.
And I am making a subset of this A, S. So what are the possibilities? The possibility is either this A will be the element of A or will not be the element of A.
Yes, sir.
Right? Right? So for each element we have 2 possibilities. Right?
Yes, sir.
Either that will be the member of that particular subset or not member of that particular subset. So we have, for each member we have 2 possibilities. How many members are there? 3. So how many possibilities are there? 2 into 2 into 2. 2 raised to the power 3.
Yes.
Right? Similarly, if I will have n elements are there. A, B, C up to n elements. So for each element we have 2 possibilities. So how many possibilities are there?
2 to the power
n times.
2 to the power n.
Right? So we will have in total 2 raised to the power n possibilities. In YouTube, Gaurav.
Sir, why are we multiplying 2 into 2 into 2 and not adding? Because for every element.
Okay. Your doubt is in Hindi say Jayaz. Your doubt is Jayaz, not Hindi, I guess Urdu.
प्रिंसिपल ऑफ काउंटिंग रहेगा ना इसमें तो बेसिक.
Let's see. Suppose I have 2 pens. Okay. Usual example is this. Very common example. I have one red shirt and one blue shirt. Okay, and I have 3 pens. What kind of pant it is? Suppose white pant is there,
yellow
blue pant is there, and yellow pant is there. Okay. So how many combination I can make? For each member we have 3 combination. 3 for each. For red shirt I have 3 possibilities, right? I can wear my red shirt with this white pant, blue pant, and yellow pant. Okay. For blue shirt also I have 3 possibilities, right?
Yes, sir.
I can wear with these 3. So someone will say, why you are not taking 3 plus 3? Why you are taking 3 into 3? Let's see. In first day, I have wear this one. Right?
Yes, sir.
Okay, just a minute. Oh, no, it's correct, I guess. Just a minute, okay.
Sir, the red shirt will get mapped 3 times and blue shirt will get mapped 3 times. So the total will
It's
be
3 plus 2, 6. No, it's 3 plus 2, 6. This is not the correct question.
Yes, sir.
Example for that.
Yeah,
just a minute. I will give another example. Okay, I'll give you the small example where you will get 9.
My point was, sir, though the answer of this, that the cardinality of this set might be 2 to the power n. That is correct. But the explanation that we are understanding for this, that each element can either be inside the set or can be outside. So in that way, only 2 possibilities are going to be there for each element. So, uh, so if there are 3 elements, then obviously there will be 6 possibilities only. But yeah, if we take subsets of elements and then maybe try to understand that how many this one what will be the cardinality, then it can change. Or so you may explain. I was just trying to say what I understood based on that.
The thing is, you are saying, sir, in the possibility thing, why you are getting this multiplication, why you are not taking the addition?
Yes.
Right?
Right, sir.
This is your question. That's what I'm saying.
Yes. Right, sir.
Sir.
Yes.
Sir, in proper maths language, it is said to explain this topic. May I share that?
Yes.
सर टू मैप जैसे सिर्फ ए को मैप करने के लिए 3C1 तरीके होंगे और दो ए बी को मैप करने के लिए 3C2 तरीके होंगे और तीनों को मैप करने के लिए 3C3 तरीके होंगे और जो जीरो चीज़ों को मैप करने के लिए 0 तरीके होंगे। अब इन चारों का सम होगा 3C1 3C2 3C3 और 3C0 का, ये 2 to the power 3 आएगा जो कि 8 होता है। तो नंबर ऑफ सबसेट्स होंगे एंड NC0, NC1 till NCn, which will be 2 to the power n.
Correct.
Yes, sir.
Correct. The thing is, in this example, we were taking only the what subset. Sometimes what I will do, I will wear only this shirt only. Okay, someone will say, I will wear only this shirt, and sometimes I will wear only this this blue shirt. Red shirt was there and blue shirt was there, no? Sometimes what happens is, I will wear only red shirt, I will not take any of this member. Okay, and sometimes I will wear only blue shirt and I will not wear any of this element, and sometimes I will not wear anything. Right? In the set example, this thing is if I am making the subset, what I am taking? Sometimes I am not taking any kind of element. Sometimes what I am taking only one element. Right?
And sometimes it's cold, then you take both the shirts.
Yes. So these are the possibility here I was neglecting. Now I have to consider all those possibility. Now you understood?
Yes, sir. Sir, can you go back to the power set of to the power set, sir?
This is the power set, no?
No, sir. Just this one, where you defined it, correct, sir. So, sir, here like A, B, C, and so sir, that is fine, that A, B, C is there, and whether it is there or not, based on that, it will be, the cardinality will be there. And so that way, for each element, 2 options are there, whether it is there inside the set or it is outside the set. So that way, 6 possibilities are there for this.
No, that is 9 possibilities.
No, sir, that's fine. 9 possibilities. No, for A there are 2 possibilities. For B again there are 2 possibilities. For C again there are 2 possibilities. 2 plus 2, 6 possibilities, and then there are more possibilities also. But how to like we simply defined that for these 6 possibilities, we were able to very clearly say that an element is there inside or outside. That's why there are 2 possibilities, and so we were able to reach this number 6 possibilities. We have understood. So how to actually understand or define the rest of the possibilities and then add to get this 2 to the power n?
Sir, he is getting confused in inside and outside one thing.
Yes. The thing is, whenever you will form a subset, okay, suppose you have set A, 1 and 2. This is the only 2 elements are there. Now, if you will form a subset A from this set S, what is the condition for set? I will take any small subset. I will take a small collection of this set. It means, first of all, what is the definition? The definition is saying this implies X is inside the set. It means that if I need to form the subset of this particular set, what I need? I will take some elements or I will not take element. This is the case, right? So if I will see this one, what happens is, the thing is, in that case, either this one will go to the inside or will not go to the inside. This is the two case will happen here, right?
Right, sir.
This is only two case, right? Two case for this person, two case for this person. Okay.
Correct, sir. Correct, sir.
Correct. So in first case, suppose both are not going to inside. So I will get this empty.
Right, sir.
Right. Suppose in second case, both are inside the case, inside the sub A. Then I will get this S. Right. In that case, no one is inside. In this case, I will get both are inside. So I will get this.
Okay, sir.
Right. Third case, what happens is, this is A1. This one is inside, but this is saying, no, I am not going with you. So only one will get three case.
Right, sir.
In last case, what happens is, two will say, if you are going, I am not, two will say, I will go, you will not go. Then I will get what?
Only two.
So how many cases are there?
Four.
Right?
And sir, if you put a 3 here, one
exactly. In 3 case also you will say like that. This is the 3 case, right? First case, everyone is inside. Second case, no one is inside.
Right.
Third case, B and C will say, I will not go with you, so only I will get A. Similarly for B, C, I will get like that. Now, and in this case, A and B will come to the picture, and then they will say, we are only 2 will go. And in that case, C will not go. Similarly, here A will not go, here B will not go. Okay. We are taking combination, possible combination. Okay?
Yes.
In that case, if we have to count, we have to multiply the possibility, not add the possibility.
Okay, sir. Got it, sir.
Okay.
Thank you very much, sir.
Okay. So we have discussed about the power set and their cardinality. Okay. Interval, everyone will know what is interval. It's easy, right?
Yes, sir.
Interval, basically, it's a set and it's representing like this. Either close interval, this is open interval, this is known as close open interval, and one more thing is there.
Open close interval.
Open close interval. Okay. So we will define one by one. It's a set basically. We will discuss about the real number. So we will take all the real numbers such that this happens. Everyone will understood what is this, right?
Okay, sir.
Yes, sir.
Right? We will take all the elements in between. Suppose this is my A, this is my B. So what I will take? I will take including A, this portion I will take. Okay. In this case, in the first case. Okay. In this case, what I will do? I will take all the X here. This happens. It means that I will not take. In this case, what we will take? This is my A. This is my B. So I will not include the endpoints. I will include only these points. Okay. Similarly, here you can say what? A is included, B is not included. Okay. Now you understood, right? The last
Yes,
one, what
sir.
will happen?
That close
Easy.
bracket will include and open bracket will exclude the value.
Yes. Yes. Okay. Now what is further?
Sir, I have some water. I
That
think you are exhausted.
yeah. I will give you 5 minutes break. I have already told you this class will be like around 2.5 hours or most probably 3 hours. It happens in my class, most probably class duration will be around 2.5 hours. I'll give you 5 minutes break. Okay.
Okay, sir.
No, sir, you are exhausted.
Time is. We will meet 8:57. Okay.
Okay, sir.
In the end of the class, I will download this particular notes and I will share in the chat box itself. Okay.
Okay, sir.
Okay, sir.
Thank you, sir.
Okay, sir. Okay, sir.
Okay. Who are not from mathematics background, are you able to understand? Hello. Is there anyone from mathematics, non-mathematics background here?
Yes, sir.
Are you able to understand, Bala?
Yes, sir. Is it able to understand? I have doubt in rational numbers, sir.
Sorry?
I have doubt in the rational numbers, sir.
Yes. What is the doubt?
For example, 2.999.
Okay.
The decimal 9 was exponent for 5 times. Is it a rational number or irrational number? We can write it as a.
Could you take a screenshot of that particular question and paste it here so that I will see what?
Okay, sir. Wait a minute, sir.
Is there
Sir?
anyone? Any other person?
Sir?
Yes. Yes.
Can you suggest a simple book for practicing the kind of questions we are expecting in this particular course for that?
See, the thing is, if you will a proper practice for your assignments, your your mock text, and your previous year question, you will be able to qualify the exam. Exam will be not that much difficult. That will be easy. Okay, there are books, but you don't have that much time. You have 4 courses, right? And only 4 weeks that
Yes,
you
sir.
have. You
Yes,
will
sir.
not get that much time for that.
Sir, how can I base this?
So we have to concentrate only on the course material and the
Yeah, you just concentrate with that. But if you will, you are getting that much of time. I don't think so. In Math 1 course, class 12th level will be enough, I guess. Or if you will go with more than that, you don't need to go because the course, that particular Math 1 course is too
theory
easy.
part is okay, sir. Theory part is okay, but to increase the speed and to get a sense of variety of questions.
So I have a question, sir.
Yes.
So can I
Yes,
ask my
Bala.
question?
Yes, yes.
Yes, sir. I sent the question, sir.
Yeah.
The chat box.
Yeah, yeah. Yes, what is the question?
The question is,
Yeah, what is the question, Bala?
the question is, I can't able to differentiate between the rational numbers and irrational numbers. I know irrational numbers are
Here,
pi, e, and other elements. But irrational numbers, you can able to see the question in the chat box, sir.
this is from a graded assignment, right?
I can't find any other examples for it, sir.
Okay, so what is the difficulty here?
Difficulty is, for example, the option 1. Otherwise, if we take the option 2, 2.999, because exponent like this, we can multiply it by how many decimals after the how many decimals, and make
Then
it
you
as a
will,
rational number.
yeah, then you will get the rational number. Then it will be the rational number only. You
Then
just
it is
need PYQ
irrational.
form. You just need PYQ form, right? No matter what you will like what you will do. But whatever you are doing, that will be mathematically correct.
Okay, sir. The same, for example, the option 1, the root of 6 plus root of 3. We get some 2.7865 something.
So how will you manipulate this root 6 plus 3? For that, you have to do rationalization here.
Sir, we'll do the thing by calculators, sir.
Don't go with the calculator. Okay. Why? Because calculator will approximate the value. It will not give you the correct answer. So please don't go with the calculator. Just do mathematics, like do manually. Then only you will find the answer. Otherwise, you will.
Hi, sir.
You will find the incorrect answer. Yes.
Yes, I have a question, sir, from the activity question, sir.
Yes.
So it's activity question 1.10, question number 7.
Just send me the screenshot.
Okay, I'll just do it. Yeah.
Okay, so you understood. Don't go with the calculator. Just try to solve with manually. The easy questions are there.
I have to simplify the questions and
yes.
Okay, sir.
Correct mathematical way.
Okay, sir.
Okay, what are the tools you have? If you are not able to simplify, then that will not be the rational number. That will be the irrational number. Just a second option, you can directly see and say it's a rational number, right?
Okay, sir.
Sir, can I ask one question?
Yes.
Can you explain complement content?
Yes. Complement content. We did not discuss up to this. I'll start by 9. Okay. Most probably in 1 hour, I will try to wrap up all those things.
Okay.
Sir, I have a question about intervals.
Yes, what is the question? Quickly
Sir,
ask.
if we have to write infinity, plus infinity or minus infinity, should we use open interval or closed interval?
We will use only open interval.
For infinity.
Yes, because it's not specified.
This way. Because we don't know about this infinity. What is it? It's just a concept, not a real number.
Excuse me, sir.
Yes.
I have a question, sir.
What question?
Sir, like the content of week 1, all the videos that I watched, it's more about theory, like when it comes to relations and functions. But in practice questions and in graded assignment, they have asked like different problems, right? Like how do you solve it? Like how do you approach? I can understand the theory, but the application part, what are the steps?
Okay, just we will go with the relation, then we will try to discuss those doubts as well. Okay.
Okay, because
don't worry. Once you understood the concept properly, you will be able to understand. You will able to solve that question. The question is not that much difficult, but the thing is, you have to feel that concept, not even understand. Feel that concept. What is going inside there, that particular thing only. Once you understood that thing, you will easily solve that question.
Okay.
So I send the question.
Problem, the question number 1.6 of activity 5.
Okay, okay. One thing that you guys can do. See, since I am getting so many questions from activity, that's why I have told you, just make a WhatsApp or Telegram group, whatever you want, and discuss your problem there itself. Okay. There is a strong possibility that your classmate they have already solved that particular question. So this will be easy for me, right?
Yes, sir.
So that
So can you
I
take the
will
question? So
explain.
I just sent a question right now.
Which one? Janak,
It was
right?
yes, sir.
So what is the doubt here?
So I want to know why is 0 included in the counting of like the question, like the answer has 0 included.
0 included here.
Yeah, like it doesn't mention anything about natural numbers in context of counting, but 0 is included in the cardinality.
Just a minute. What is the question? Let P is a subset of this S process. What is S?
It should be a set.
Yeah, it was
Any set.
Yeah.
Is there any comprehension type of question? Like there is a big part above the question, that kind of thing is there?
Yeah, hold on.
Sir, I think R represents for real numbers here, which is why
So
0
it
is
is
included.
the snail frog. Wait, I'll take a screenshot of that.
Here, sir, 0 represents the phi set or the null.
Yes. For null, 0 represent. Yes.
Yeah, that's why the here cardinality of P is considered as 0 also.
That's correct. They are asking for cardinalities. Okay, let's move further. Okay, union. Union is an easy thing, right? Union
sir.
of union.
Yes, sir.
Two sets or three sets, whatever you will say. I am taking A and B. So represented by, I am not writing a formal definition. You will get the formal definition in the book, or you will get the formal definition in your lectures, official or professor's lecture itself. So A union B, basically it's represented by this union sign. And how it's defined as, we will collect all the element X such that either X is inside A or X is inside B. For example, if you have A like this, 1, 2, 3, and B like this, AB. So what will be my A union B?
1, 2, 3, A and B.
1, 2, 3, A,
1, 2, 3, A and B.
Easy for everyone, right?
Yes, sir.
Yes,
Because
sir.
either it has to be inside A or it has to be inside B.
Yes, sir.
Similarly, another example, if I will take A as 1, 2, 3, same, and B as 1, 2, 3, 4, 5. Now, what will be my A union B in that case?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. It's not like I will write 1, 1, 2, 2, 3, 3. No, right? Because it will not form a set. So I need only one. Okay, I avoid the repetition part. Understood?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Intersection of.
Hello, sir.
Yes, sir.
Yes.
Sir, I have question. I know what injective, bijective, and surjective, but I cannot use in a numerical value. Can you explain?
What injective, bijective, and surjective? And
Yeah, I know, but I am not used in a numerical value. Like function, what is a like function is not used.
okay. Can I will tell whenever I will discuss about function?
Function is a, sir, function.
No. What I am saying whenever I will discuss about the function, you just ask that doubt there itself, okay? Because here I am explaining intersection, then I will go to the function. Someone is there, so definitely I am sure here there will be one person who did not watch the video and he has no idea about the function. Okay.
Yes.
So if I will directly jump with the function, that particular thing will be difficult for him, right?
Okay, sir.
Yes, that's right. So intersection will be represented by like this: A intersection B. This side, remember this side, I define as A intersection B is equal to for all collection X, such that X is inside A and as well as X has to be inside B. Don't ask for numbers. Just paste your group link here. They will join if someone wants. Okay.
Okay, sir.
Understood this? So example, suppose A is equals to like this: A, B, C, and B is equals to A, B, D, E. So what will be my A intersection B?
AB.
A or B, sir? I just need to find the common element, right?
Common elements of A and intersection B.
Right, A and B. Similarly, if I will give you the example like this: A, B, C, and B like this, 1, 2, 3. Now, what will be my intersection?
No any element, no common element.
There is no common element, so this will be empty, right?
Empty site.
Empty.
Right? Understood? Okay.
Yes, sir.
Yes, sir.
Let's discuss about set difference.
And then now the cardinality of A intersection B is 1.
Cardinality of A intersection B is 1. Here 0, no?
Empty set is considered as a
cardinality of empty set is always 0.
Okay.
1, it means there is one element inside that set, but here nothing is there.
Okay, sir.
Okay. Okay, set difference. Set difference is represented by, again, it's represented by A difference B and defined as A difference B is defined like this. We will collect all the element X from A. Okay, we are taking elements of A such that X is not inside B. Okay, what we are taking? We are taking X which are inside A and which are not inside B. What does it mean? For example, if you have A like this, 1, 2, 3, 4. Okay, and B is like this, 2, 4, 6, 8, 10, 12. Okay, now what will be my A difference B?
1 or 4, sir.
Right? I have to exclude
2, 4.
So I have to exclude the elements of B, right? So I will
2 and 4.
Just listen to me carefully. What I will do, I will pick 1 and then I will see if this 1 is inside B, I will not take inside this set. So what I need to check, I just take 1 and then see 1 is inside this element, this set or not. 1 is not inside this set, I will take 1. Now let's move towards 2. Take 2 and then see either 2 is inside this set B or not. So we have find 2 here. It means that 2 will not going to taken in A difference B. Right? Now let's move towards 3. Pick 3 and then see 3 is inside this set or not. Please mute yourself. Please mute yourself. So Ravi, please mute yourself.
Sorry, sir.
And now take 3 and then see 3 is inside B or not. No, right? 3 is not there. So I will take 3. Now take 4. Then see 4 is inside this B or not. So 4 is inside this B. So I will not take 4. So this will be my A difference. Right?
Yes,
Okay, sir.
Right? Similarly, if I will ask about B difference A. So B difference A, it means what? Basically, I am taking X from B who are not inside A. Right? So what will be my B difference A in that case? So what I will do in that case, I will pick B elements of B and then see they are inside A or not. So I am picking 2, first element. First element is 2. Now I am seeing 2 is inside A or not? So I can see 2 is there. So I will not take 2. Now let's move to the second element. Second element is my 4. Now see, 4 is inside this element or not? Yes, I am taking. I can find 4 is there. So I will not take 4. I am not taking 2. Now let's move towards 6. Now see, 6 is there or not? So I can easily see 6 is not there. So here 6 is there. Please mute yourself. Avinash, mute yourself. Avinash. Okay. So 6 is there. Now let's move towards 8. Now see, 8 is there or not? No, right? So 8 will be there. Similarly, you can see 10 is not there. So 10 will be there. And 12 is not. So this will be my Bay difference, 8. If we will go with the Venn diagram, so what will the case? Okay. This is my Venn diagram. This is universal set, and this is my set A, and this is my set B. This is my A, this is my B. Now, A difference B means, what does it mean? What does it mean? I need to take elements of A which are not inside B. It means that I am taking this portion only. Right?
Yes, sir.
This portion. Are you able to see the color?
Yes, sir.
Yes, sir.
I am not taking the intersection part. Okay. If what do you mean by B difference? Are you able to see this red color?
Yes, sir.
Okay. So
Yes,
what
sir.
will be my B difference? This one.
Yes, yes, sir. Is that right?
Except A intersection B.
This one. Okay. And this part, this part is my A intersection B. Okay. And this whole thing is my
A
A
union B.
union
B.
A union B.
Yes. Sir.
This whole thing is my A union. Understood?
Yes, sir.
Got the idea? Okay.
Yes,
Now
sir.
what else? Okay. Here our set part is done. Okay. Now further we will move towards relation. Okay. So for that we need to discuss about Cartesian product.
Sir, what is complement of a set?
Yeah. Sorry. I forgot that.
That's okay. And symmetric difference.
Sorry.
And symmetric difference too.
Symmetric difference is there in your course? I don't think so.
Okay, sir. I'm sorry, but
Hello, sir.
Yes.
Sir, set comprehension.
Set comprehension is done now.
Okay.
Set complement is remaining. I forgot that. Symmetric difference is not there in your course. Okay.
okay, sir.
So you don't need to. It's a little bit like tricky. This one, na? There's no need to discuss.
Okay.
It's not there in
Yes,
it.
sir.
If they will ask something from there, they will firstly they will define what is it. Okay.
Acha, okay, sir. Okay.
Basically, we will not discuss this part. Except this part, we will take all those things in this symmetric difference.
Okay, sir.
Okay. No need to discuss. Let's see the complement. Okay. So for that, I need some bigger set S. This is my set S. This is my universal set, you can say. Okay. Then A complement is nothing but, and A is a subset of S. This is necessary. Then A complement is nothing but set difference of S and A. Or we can say we will collect all the element of S which are not inside A. And in the Venn diagram, what I will say, this is my S, universal set S. Suppose this is my universal set S, and this is my set A. So what is my, this is my set A. And what will be my A complement? This portion. Okay.
Yes, sir.
Except this portion will be my A complement.
Okay,
It's
sir.
easy to see. This is my A. Okay. Just like in real number case, if we will discuss Q complement. So Q complement is what? R minus Q. This is basically irrational number, right?
Yes, sir.
Okay. Now let's move further.
Sir, I have a
Okay,
question.
so yes,
सर जो प्रोफेसर सर कैन आई आस्क इन हिंदी?
yes.
सर जो प्रोफेसर ने वो दिया था वीडियो, उसमें उन्होंने जब कहा था कि अगर एक होल नंबर डिफाइन करना है तो 0 1 2 3 डॉट डॉट डॉट, तो जो ये डॉट डॉट है उन्होंने कहा था ये इनफॉर्मल तरीका है रिप्रेजेंट करने का, राइट?
हाँ,
सर
that
तो
is not
फॉर्मल
formal.
तरीका क्या है? उन्होंने बताया नहीं था.
Set comprehension form is a formal way. Why that is informal? Because I cannot, we are representing in the roster form, but what is roster form is same. Just write each and every element of this set. But if you have to discuss about this natural number set, what you are writing 1 2 3 dot dot dot, right? What do you mean by this dot dot dot?
Yes, sir.
Right? That is why we will say this is an informal way. Formal way is just write set of natural number.
अच्छा, okay, sir.
0 is in.
Okay.
Okay. This is our formula. That is why set comprehension is coming to the picture. Okay. Sometimes what happens is I cannot give the example of my set. I cannot give the set comprehension form of my set. Just like that example, pi minus 40, Rohit. That example, I am not able to find the set comprehension form for this example. Right? But I am writing it as roster form, so I can use any of them. But it does not mean that another person will not exist.
Okay, sir. Okay. Thank you.
Okay. Okay. So Cartesian product. Cartesian product is this easy. It's easy, not that much difficult. Okay. When is your deadline? Deadline
On
for
12th.
graded assignment?
12th June.
11:59 p.m. 12th June.
Okay. Most probably Sunday's session I will not take. Some other instructor will take some for some obvious reason. I hope some cricket premi will know what is the reason. And most probably I will not take that session. Some other person will take. But Tuesday session, some other another instructor will take. We will meet by Friday most probably, and Friday, Sunday, and Thursday. Basically, before qualifier, I will take most of the your session. After that, I will resign this job, so I will not be there. So some other person will be take the sessions. Okay.
Okay, sir.
Okay, sir.
When was the week 2 content released? Once your week 1 will be over, your week 2 content will be released. Okay. So only 1 week difference. Most probably this Monday, by this Monday or Wednesday, you will get your week 2 content.
So I think
Okay.
the schedule date is today, I think, if I'm right, according to the table that they have shared.
If it's scheduled by today, so it will release by today itself. By the evening or midnight or tomorrow morning, you can say. Okay.
Okay, sir.
Don't need to concern. Firstly, watch week 1. See, the thing is, what happens is, most of the person who are sitting here, I am expecting you have watched all the lecture. But the thing is, most of the person who are coming into the class, they will not watch the lecture. They did not watch the lecture and directly come into the class. That is why what happens is, they will not able to get the concepts. Okay. If you have watched the lecture, you don't need to watch these lectures itself. They have already explained in a very precise manner.
Yes.
Okay.
Yes.
They have discussed each and everything. This is kind of summary session, but the thing is, those who are not comfortable with that session, they will attend, because some of the person wants to join a live session. They want live session. That is why this kind of session is happening. Okay.
Yes, sir.
Okay. Let's move to the Cartesian product. Suppose A and B are non-empty set. Okay, Cartesian product always defined on non-empty set. Then the Cartesian product is represented by A cross B and defined as follows. How is it defined? A cross B equals to, we will take pairs of A and pairs of element of A and B, where first entry will come from A and second entry will come from B. Okay. So what we are taking, we are collecting all the pairs of elements of A and B, where first element will come from A and second element will come from B. Okay. If someone will say, sir, then what will be the Cartesian product of B cross A? This will be look like BA. Here B will come from B and A will come from A. Okay. Here order matters. Remember, order matters. Who will be in the who will sit in the first? Their respective elements will be like sit in the first itself. Okay.
Okay, sir.
Yeah. Question, Jisan, question practice session will be happen on most probably Tuesday or Sunday. Okay. Where you can ask the question. And one more thing, most probably TA session is basically for question practice only.
Yes, sir.
Okay. So you just join the TA session there where they will solve the questions. Okay. Okay. This is one thing. Okay. For example, if you have A is equals to 1, 2, 3 and B is equals to AB. Okay. Now what will be my A cross B? Take 1 and take all the possible pair. For 1, 1B. Now 1 is done. Now move for 2.
2A and 2B. Yep.
2A and 2B. I have a small example for that. I will definitely give. Then 3A and 3B. Okay. How you can remember this kind of thing? Again, let's move to the Rohan family. Who was there in Rohan family? Rohan itself, his father, his mother, his sister 1 and his sister 2. Now he has decided to get married. So his girlfriend, suppose
Sir, there is 2B.
Sorry?
Sir, there is 2A but not 2B.
Yeah, sorry, I forgot.
No problem.
Okay. Suppose Rohan wants to get married with his girlfriend. What is his girlfriend name? Can someone please suggest? Ria. Okay. Ria. And Ria's mother is there, father is there, and Ria's brother is there. Okay. Now initially now Rohan wants to introduce his family to Ria's family. Now how he can introduce? Whenever we have to fix the marriage, then what happens is, if you guys have seen, so what happens is what to say, this person's family will go to Ria's home. Okay, Rohan's family will go to the Ria's home, and what happens, this person Rohan will introduce each and every person, right? So what happens is, Rohan will go to Ria's home. Firstly, Rohan will introduce with Ria. Initially, he has introduced himself. Now, Rohan will meet to his mother.
Riya's mother, yeah.
Yes. Then Riya's mother. I am taking M prime. Okay. So that you will not get confused. Then Rohan will meet to his father. Then Rohan will meet to his brother. Now Rohan term is gone. Now his father will go. His father will meet to each and everyone. Right? Then Riya will say namaste, namaste Sasurji kind of thing. Okay.
Okay, sir.
Okay. Then father will meet to his mother, namaste Samdhanji. Then father will meet to his father. Order will be changed. I am seeing order. There is a possibility that father will firstly meet to his father only and his brother. So you have seen this. This is the usual scenario that will happen whenever someone will get married, right? This is the way that they will introduce their families, right? So in the Cartesian product itself, we are getting married. Set A wants to get married with B. So you can remember by this way.
Hello.
Okay.
Sir, I have
Now you can
question.
remember. You can easily understood. Yes. Yes or no?
Sir, जैसे suppose A set is some element or B is empty, then A cross B is a Cartesian product.
I have already told you, na. A and
Yes,
B
sir.
are non-empty set. Suppose in that example, if there is nothing, Rohan is not exist and Rohan family is not exist. So with whom Riya will get married?
Yes, sir.
Not possible, no?
No, sir.
So both set has to be non-empty.
Okay, sir.
That is why in the definition itself, I have mentioned that A and B are not empty.
Okay.
Got the idea?
Okay, sir.
Got it?
Yes,
Okay. So this Cartesian product done, na? So in that case, let's discuss about the cardinality. Suppose cardinality of A is 3, cardinality of B is 2. What is the cardinality of A cross B?
6.
3 cross 2?
Yes.
6, right? Easy? Easy,
Yes,
right?
sir.
Similarly, if your cardinality of set A is n, cardinality of set B is m, then what will be the cardinality of A cross B?
Amen.
M into N.
Mn.
And cross and
And mn to n. Easily. You can see. Now, my question is just obvious question. Does A cross B can be empty?
Yes, it can
No,
be empty
no.
if one of those set is
Non-empty
0.
set, sir.
Not updated.
No, right? Because in the definition itself, we have taken A and B are not empty, non-empty. So this Cartesian product will always non-empty. It means that this thing, cardinality of this is always greater than 0. Okay?
Yes, sir.
This is the obvious question. Okay, now let's move towards relation.
Sir, if A and B are empty, then A cross B will be empty.
But in the definition itself, we have already mentioned those things. A and B cannot be empty.
Okay.
Then you just assume the marriage. Okay. If both set are empty, then you just assume the marriage. That's it.
Okay, sir.
Okay. Let's move to the relation. Now interesting part is coming. Relation. Nothing. It's nothing. Any subset R of this Cartesian product. Okay. Any subset R of this Cartesian product is known as relation. Okay. Any subset. No matter. It can be empty itself. R can be empty because I am taking subset. And R can be A cross B itself. Okay. So any subset of R of A cross B is known as relation. Okay. Now here itself, I forgot to mention that you can define A cross B cross C itself.
Sir, here I have a doubt.
Yes, Cartesian products of three set. Just a minute, I will just define this. This is basically A, B, C. Here I will take triplets. Here A is coming from A, B is coming from B, C is coming from C. Okay. You can define like this. You can take n set as well. Yes, what is your doubt?
Cartesian product is mandatory not equal to a relation. Is it
Not
mandatory?
mandatory. It depends on the definition of relation.
Yeah. Okay.
I will. This is one of the definition of relation. Okay. I will give you another one, and third one, and why it's a subset of A cross B. Basically, that I will tell you. Don't worry. Okay. Now this is the one way to define a relation. Let's move to the actual way. What is relation? Suppose we have two families, family A or family B. In real life, what is relation?
Like relation with family.
Huh?
Brother.
What is relation in real life?
Relationships like in families or something.
In families. Just dictionary meaning. I am asking
Something
for
which
just
is connected.
yeah, some rule for which we can connect both of the families, right? Some specific rule by which we can connect both families. That kind of thing is known as relation, right?
Yes, sir.
Some certain rule. I am not saying what that rule is. I am not able to find that rule itself. Sometimes I am not able to find that rule. Right?
Yes, sir.
Your relation with your mother, yes. Mother-son relation, you can say. Many kind of relation it is. There will be many kind of, infinitely many relation. But the thing is, the relation is what? If we will discuss about its dictionary meaning, so what its dictionary meaning? That is, relation is something, some rule by which we can connect to families, by which we can connect to elements, by which we can connect to members of the families. No matter the family are equal, the family are different, right? Right?
Yes, sir.
Right. So basically, suppose I am taking in the NCERT book one example which is very common. Suppose here we have cities. Okay, cities name. Or if we will discuss about your example, mother-son example or a teaching example, something like that. There. Suppose in this set you have a teacher's name. Okay, here Rani is there. They are teachers. Okay, Rani and Rohan and Ravi. Okay, Vignesh is there. I remember this name. Sorry, Vignesh. I'm using your name. Ravi is also there inside the class, right? Okay. Then Mohan is there? No, Mohan and Mahesh. Okay, and there are three subjects: math, physics, and chemistry. Okay. Now, in that relation, in that thing, we have to map like that. Suppose Rohan is Rohan is a math teacher, so we have to map with math. Suppose Rani is a chemistry teacher, so we have to map with chemistry. That kind of relation. The teacher, they can teach that particular subject. Okay, who can teach that particular subject. So suppose this is a relation which is showing that particular teacher can teach that subject. Okay.
Okay, sir.
Okay. From A to B, how we are defining? We are defining this relation like that. that particular teacher can teach that particular subject. Now, Ravi can teach physics. Now, Vignesh also can teach physics, and as well as Vignesh can teach mathematics. And Mohan can teach chemistry, physics, and mathematics itself. So, how we are saying? We can say Rani can teach. It means Rani is related with chemistry. Okay. Then Rohan can teach what? We have said Rohan can teach math. Then we have Ravi. Ravi can teach physics. Okay, just for your reference. Vignesh can teach math, as well as Vignesh can teach physics. And Mohan can teach all of this.
Yes.
Mohan can teach math, physics, and chemistry. Okay. Okay, this is the way that we can write, right?
Yes, sir.
Now, if I will see here, I am getting one element from here. All these left-hand side elements, are coming from this set A, right? And all the right-hand side elements are coming from this set B, right? So
Yes,
rather than writing like this, I can write just like this. Ravi chemistry.
नोटेशन वही है सर। ये फंक्शन वाला इसके बाद वाला चैप्टर ये पढ़ लियो, उनका भी पढ़ लियो।
Please mute yourself.
इसमें एग्जांपल भी है देखा।
Please mute yourself.
नहीं कोई चित्र नहीं है इधर।
Rajesh.
Okay, I can write like this.
मास्टर है।
Please mute yourself. Who is
Yes, sir,
speaking?
you can write like
Rajesh. Rajesh, mute yourself.
तेरी किस्मत इतनी अच्छी रही कि
Rajesh.
वो relevant।
Okay. If someone will not mute themselves, I will mute from here. Okay.
Okay, sir.
Now, Vignesh math. So, what is the trend? The trend is, rather than writing this, I will going to prefer like this. Now, if I will ask what is my relation and what kind of relation it is, I can write it as like this. Sir, Ravi and math is there, right? These are the element inside the for this relation, right?
Yes, sir.
Right?
Yes, sir.
And like that. If you will closely see, this is nothing but this is a subset of A cross B, right? Because in A cross B, what kind of set is this? We are taking A and B, where first elements are coming from A and second elements are coming from B, right? So if you will closely see of this particular set, this is nothing but this is a subset of A cross B. That is why we have defined initially any subset of A cross B is a relation. Okay.
Yes, sir.
And in formally, what we can say, a relation is a rule for which we can connect two sets, or for which we can connect elements of two different sets, or two sets only, not different set, two sets. No matter they can be same, they can be different. Okay.
Yes, sir.
Okay. If for see, there is a this is one thing. There is a possibility that in that relation we can also connect another set. See, okay. Suppose someone have lab itself, so math lab and physics lab and chemistry lab, and that kind of thing will come. So we will define like that. Suppose he can handle as well as chemistry lab, but he cannot he can handle math lab. So here we are making connection between three sets. So this is also a relation, right?
Yes, sir.
Right. So relation is basically what? Here this will become a subset of A cross B cross C, right?
Yes, sir.
right? So what we have observed here, we have observed that this relation is nothing but this is a subset of A cross B or A cross B cross C, A cross B cross C cross D, okay, or subset of Cartesian product. Understood up to this? What is relation basically?
Yes, sir.
Yes, sir.
This definition is important. Okay, now if we will discuss about, we will discuss about only two sets. Then this relation R is called two sets, say A and B. This relation R is called binary relation. If we will discuss about three sets, then this relation is called tertiary relation. Okay, so here this is called binary relation.
Okay, sir.
Understood? Because we are using only two sets for defining this relation. Okay, if we will use three sets, then it will be tertiary relation. Got the idea?
Yes, sir. Okay.
Okay.
Yes, sir.
Now, basically, in that case, we will only discuss about binary relation. Okay. Further, we will discuss about binary relation. So you understood what is binary relation? If we will discuss about only two sets, if we will define a relation between two sets, then that set will be binary relation. Okay. Understood?
Yes, sir.
Okay. So suppose, so we will discuss about types of binary relation. So someone will say, sir, is there any relation which are not binary relation? Yes. Yes. What kind of relation it is? If you will take the relation in A, B, and C, then that kind of relation will be tertiary relation, not binary relation. In binary relation, usually we will discuss about two sets. And here, now, if I can define a relation between A and B, similarly, I can define relation between A and A itself, right? So this kind of relation is known as relation on a set or binary relation on a set. Why? Because I am defining this relation in same set, right?
Yes, sir.
So this relation, if R is defined between A and A, is known as binary relation on a set. Okay, so we will discuss only here, we will discuss types of binary relation on a set. Any doubt up to this? See, what is binary? I am again saying, I am again saying, what is binary relation? If in a relation, here I am writing, okay. If in a relation, I am using, this is not formal definition, informal, okay. I am using two sets, A and B, say A and B, then that relation is called as binary relation. Okay.
Yes, sir.
If in a relation two sets are involved, so that relation is known as binary relation. Okay.
Yes, sir.
And what is binary relation on a set? It means that two sets are equal to each other. Okay, they are not distinct, they are same.
Yes, sir.
Understood? So
Yes,
we will
sir.
discuss about binary relation, types of binary relation on a set. So I am not discussing about each and every type, but what are the types are required for this course? I will discuss only those types. Okay. So what are the types that we will have? Okay. After relation, we will close this class. In the next session, what we will discuss functions. Okay. And we will take some examples. So whoever will take the session, I will tell them and you guys will tell them. They will start from relation itself. Oh, sorry, function itself. Okay. I will complete all relations here. Okay.
Okay, sir.
Again, I have to everything is clear, right?
Yes, sir.
Up to this?
Yes,
Yes,
sir.
sir. Yes, sir.
सर क्वेश्चन प्रैक्टिस करना है तो कहाँ से करेंगे बता दीजिए एक बार
Assignments is there, right?
सर तो उसके अलावा क्योंकि असाइनमेंट में बहुत ज्यादा थ्योरी
If you have time, you just go with JEE material, but it's really difficult. It will be really difficult for you.
नो सर आई एम ऑलरेडी अ जेईई
So,
एस्पिरेंट
if you are JEE aspirant, then you just go with JEE materials only.
ओके सर
No issue.
ओके सर
Don't worry. Question will be really easy.
ओके सर ओके
Not JEE. JEE advanced is too much.
ओके
Okay. So, firstly, what is it? Identity relation. Okay. Second thing is reflexive. Irreflexive is also there, but that is not in your course, so I am not going to explain. This is reflexive. Then symmetric. Then anti-symmetric. Then transitive. And lastly, equivalence. Okay. Asymmetric relation is also there, but that is also not important for your course, so I'm not going to explain that one as well. So these are the 6 types that I will explain. Okay. I'm again asking, any doubt up to this, please ask.
So, can one element be mapped to 2 different elements in the other set in a relation?
Yes, we have seen, no? We have seen
Yes,
here.
yes.
Here, Ravi, where is it? Here, Vignesh is teaching math. Vignesh is also teaching physics.
Okay. Yes, yes, yes. All right.
That thing will not happen in functions.
Yeah,
Okay, but
exactly.
relation, that thing is allowed. Okay, any other doubt up to this? There is a possibility that no one will teach anyone. Suppose here Sohan is there. Sohan cannot. He is what to say? He is a computer operator. He will not teach any subject. Okay, so he will not map to anyone.
So that is also possible, right?
This is also possible.
Oh.
So here's the doubt, like just now you mentioned about Sohan, but if he's not actually in the faculty list, why he would be part of that list? No, is it?
He is a computer operator.
But still he'll be part of the.
Suppose he is teaching Hindi, but Hindi is not mentioned in the subjects.
Oh.
Here only math, physics, chemistry are there. Suppose he is teaching Hindi, then he will not be the part of this subject, right?
Oh. And the other doubt is about this the same set which this thing which you mentioned previously. After this.
After
the
this.
In the binary relation, yeah. When you are talking about the same set, this thing. So here both the A and A will be identical. So it will be am I right? It will be the same. I didn't understand.
Both are same. Both are same. A and A. Basically, here we are defining this R, which is a subset of A cross A, not A cross B. A cross A. Okay. This is a types of binary relation on a set. I'm not saying just type of binary relation. We are saying types of binary relation on a set. Means in one set, what kind of binary relation we can form. Okay, what types of binary relation it is there in a some set. Okay. We are not taking A cross B here. Okay, A cross A is.
Sir, I have a doubt.
Yes. Tell me what.
I just sent a screen. Yes.
Screenshot. I did not get. Deepak. This is the graded assignment. This is a graded assignment thing. Just discuss with your classmate. I am not currently. I am not able to give the answer. Once your graded assignment topic will submit, graded assignment will submit, I will give you the solution,
Okay,
or I
sir,
will give you. Okay. So I cannot discuss graded assignment here. Because some obvious reason, it's a graded one. Okay, if I will discuss for what is the
Okay, sir, no
Yes.
problem.
Sure.
This is a really tricky question. Just verify your answer with instructor 2. Which one?
Yes, sir, it's really a tricky question.
Yeah, it's a really tricky question. I have solved that one.
Hello.
Yes.
Yes, I have shared my doubt in the chat box.
And one more thing, if someone is sharing the graded one, I will not suggest you to share the answer here itself in the class. You can discuss outside the class, but please don't discuss the graded assignment thing inside the class, okay? Because that is really confidential now. If you will, it's just like exam kind of thing. You cannot discuss exam questions in examination hall, right?
Oh, actually, I thought like the question bank will be different for each one of us. Now I'm
No.
separating.
It's same for each and everyone. Okay, let's discuss with identity relation. I hope everything is clear up to this. I'm again asking,
sir.
who is not from mathematics background, are you able to understand? Because that is important for you, okay?
Yes, sir.
Not for just passing this course, but in future, whenever you will go with programming, you need that kind of thing, okay?
Sure.
Okay, so it's not like just pass the course. You have to really understand the concept. If you are not able to understand the concept by this class, by the professor itself, you just search those particular topics on YouTube. You will find the videos which are in Hindi itself or in your regional language itself. There are plenty of videos which are inside the YouTube. Okay, this is a usual topics, usual 12th level topics. So you can find anywhere. So you have to understand. You have to really understand the topic. It's not the case that you just have to clear the exam. Okay, you can clear the exam. You need only 40 marks for clearing the exam. Okay,
Yes.
it's not the competitive thing that that particular number of student can qualify the exam. No, you just need to take 40 marks up to this from this. Okay, into your quiz one. So it's very easy for getting 40 marks. JEE student will get direct entry, I guess. They will get direct entry. They don't need to give the qualifier, but that they will definitely give the same exam, but that qualifier will be count as your quiz one exam.
Yes, sir.
Okay, and also who will be qualified this exam? That particular thing will be for them quiz one. Okay.
Hello.
No negative marking is there.
Sir, can I ask a doubt?
Yes.
While pursuing this course, can I join as a TA?
Yeah, but after completing your foundation level.
After foundation, right?
Yes. Yes.
Means when I am in diploma.
Yes. The thing is, doing a TA job it's a hectic job, but the thing is, you will you can directly go to the IIT Madras and you can live there, and it's a really great thing if you will live in IIT Madras, because you will meet some other person, you will meet some great minds, and you can extend your knowledge.
Okay.
You will,
Is there any criteria like CGP over 8 or 9? Like
you just this question you just asked to some TAs, okay? Because I am not TA, so I don't have that much idea, and I am also a newly joined faculty here, so I don't have that much idea. I am just teaching this course by previous two terms.
Okay.
Teaching
By the way,
assistant.
you are a nice person. Thank you. Thank you.
Am I audible?
Yes.
Yes, so I have shared my doubt in the chat box. So, sir,
I cannot share my mobile number. Yes. Yes.
Yes. So we have to construct one set in which A and B belongs to the natural numbers, where B is greater than or equal to A. So
where is your doubt? I'm able to.
In the chat box, sir.
Here.
So I'll,
What's your name?
no, sir. Just shared like not the question. I'll share a consonants.
What's your name?
Oh, Vignesh decides.
Vignesh. This R2, AB, where B is greater than or equal
Yeah,
to
yeah.
A.
Yes, sir.
Okay, what is your doubt here?
So, sir, we have to like 0, 0, 0, 1. Then will it go for infinite times? 0, 3, 0, 4, 0, 5.
What you are saying? Okay. What you are doing basically here? You have natural number.
Yeah.
And this R2 is what? This one?
It's a relation, sir.
It's a relation. Okay, this R. R is a relation such that you are taking pairs where B is greater than or equal to A and AB both are coming from a natural number.
Yeah.
Like that?
Yes.
Yes, you are correct.
So
you are correct. This 0, 0, 0, 1, 0, 2, this will go to infinite times. Yes.
Okay.
So that's why you have written this. This is enough for showing this particularly. You are not able to write all the element of this. That is why what I have discussed in the previously, right?
Yeah.
In the roster form or comprehension form.
Yeah.
This is
Thanks
what
a
we
lot,
have
sir.
discussed.
Yeah.
Okay. Now let's move to the identity relation. Okay, identity relation is represented by I. Okay, so I is said to be, I am not writing formal definition. Here you have to assume that A is a non-empty set, is non-empty set, then I is said to be identity relation, be the identity relation on A if and only if I is the form of like this. For all A belongs to A. What does it mean? Identity relation is basically what? Suppose we have a set A. We will like understood by the example 1, 2, 3 is there. So what will be the identity relation is in this case? This is saying, sir, this is a subset of A cross A. Yeah, it's correct. But what kind of subset it is? All the entries, entry 1 and entry 2, both are same.
Both are same elements.
Yes, both are same. No matter what kind of elements are there, if something is there inside this, the first entry and second entry has to be same. Okay. It means that if we will form this I from this set A, then what it will be? It will be 1, 1, then 2, 2, and 3, 3. Right? Right? This kind of relation it will be. So identity relation, it's easy, right? It's easy. Just see, for all, it does not like that you are forming like that 1, 1 and 2, 2. This is not an identity relation. Why? Because this happens. I need for each and every element. Right? Getting my point? What I am saying?
Yes, sir.
Okay. Now again, let's take another example. A, B, C, D, E. Okay. So I am giving you some examples. Just let me know they are identity relation or not. So this is A, B, C, D, and E, and AB.
No, sir, it's not an identity relation.
Why?
Because it contains A and B, and identity relation contains only same elements. It's an
Yes.
reflexive relation, yeah.
Right? So this is not an identity relation. Why? What is the reason? Because here it's containing A and B. But if something is there in identity relation, they will be of the form like this, XX only, right? First and second entry has to be same, and it has to be same for each and every one. It means that for A, this pair has to be inside. For B, this pair has to be inside. For C, this pair has to be inside. For D is also, and for E is also. For E is also, this pair has to be inside, right? And no other pair will be inside apart from this pairs, right? Understood?
Yes, sir. Yes, sir.
Right? Okay. So another example I am giving. Suppose you have a natural number set. Okay. So I am telling you I is equals to, I am taking A and B such that A equal to B, where A and B are coming from N. Is this an identity relation?
Yes.
Yes, sir.
Yes, sir.
Why?
Because of A and B are same,
Yeah,
and
then
A,
A
B
equal to
belong
B.
to natural number.
Yes, because I can write it as like this, because B and A are equal. And
Yes, sir.
this can be write it like this. So this is an identity relation, right? Another example. A, B such that the same set, okay? Less than or equal to B. For all A, B belongs to N. Is this an identity relation?
No, sir.
No, sir.
No. Why? Because
Because there
1,
is a
3 is
probability.
also inside I, right? In this case, 1, 3 is also inside I,
Yes,
right?
sir.
But what I need, if I is an identity relation, I need only A kind of element. But here, 3 is different from 1,
Yes, sir.
right? So this is not an identity relation. I hope you understood the concept of identity relation. What is it?
Yes, sir. Yes, sir.
Right? Now,
Yes,
let's
sir.
move towards reflexive relation. Okay. There are two definitions of reflexive relation. One is R is said to be reflexive. See, assume all those things, okay? Assume this thing. A is a non-empty set and blah, blah, blah. Assume this thing. So R is said to be reflexive relation on A if and only if all the pairs like AA belongs to R for all A belongs to A. Okay? What I am saying? For all elements which are inside A, for which if all the pairs like this inside R, then we will say it's a reflexive relation. What does it mean? Or another definition is saying if I is a subset of R, then we will say R is reflexive.
Relation.
Reflexive relation. Okay, most of the person will confuse between reflexive and identity relation. Okay, so the difference between reflexive and identity relation is reflexive relation is saying all the pairs are all the pairs of the type AA will be inside R for all every element which are inside A, as well as any other element kind of AB can be inside R. Okay, so if I will give you an example like this, A, B, C, suppose. So this R, if I will take like this, AA, BB, CC, and as well as AB. Okay, this is also an reflexive relation. If I
Yes,
will
sir.
give you another example, AA, BB, CC, this is also an reflexive relation.
Yes, sir.
Okay, so what I am saying is a relation is said to be reflexive if all the pairs of the type AA will be inside R. That's it. That is the definition only. Okay.
Yes, sir.
Okay, this is the definition. Okay, I will give you another example. Take set natural number. Okay, no one will unmute themselves. Okay, just give your answer in yes or no in chat box. Okay, and use your natural number. And I am defining a relation A such that I am taking the pairs like this A and B, where A divides B. So question is this relation is reflexive? If you guys are telling me yes, I will say why it's yes. And if you are saying no, then I will ask why it's no. I am checking name. Okay. So Sonu has said no. Sonu, can you tell me why it's no? Sonu, am I audible?
Yes, yes, sir.
Yes, why it's no?
Because sir, suppose A is a 10 and B is 5, then divides this 10 by
If
5
you
is
will take A is 10, B is 5, then
divides and divide.
It means A divides B.
Means 2.
Okay. You can
B
tell me in
divides
Hindi
A.
itself. No issue. No, it means A divides B. Here it's not A by B. It's not A by B. It's this. This is this. This is a representation known as A divides B. Okay.
Okay, sir.
This is not A by B. A bata B. It's not like that.
Okay.
A upon B. It is not A upon B. Okay.
Got it.
Yes, sir.
Now tell me, is it a reflexive relation or not? Write your answer. Now you know that this notation meaning, no? So Sonu, you are saying something. Yes, you can tell me in Hindi why it's not a reflexive relation.
सर जैसे रिफ्लेक्शन नहीं है क्योंकि यहाँ पर अगर हम एक और A एंड B जो है उसको हम नेचुरल नंबर से ले रहे हैं सपोज यस सर आई थिंक आई एम रॉन्ग बिकॉज आई अज्यूम दिस इज अ डिवाइड this words I not considering is a reflexive, but you explain that this is not divide, that is a reflexive.
Okay, let's see. Okay, so they are saying I am getting the answer because A divides A. Okay, A divide A is 1. Yeah, you guys are correct. Okay, let's do postmortem of this question. Okay, what it's saying, A divides B. A divides B means what? B can be written as like this, right?
Yes, sir.
There will be some K where K belongs to N. There will become some K for which this happens. Okay, and yes, and you can say, right? Understood up to this? Right?
Yes, sir.
Yes, sir.
So if I will discuss about AA, then I can write this A into K dot A, which is basically if I will take K is equals to, in this case, if I will take K is equals to 1, or here from here you can say A minus KA equal to 0, right? I am taking this AA pair, right? It means then B equal to A in this case. Understood up to this?
Yes, sir.
What I am saying here, A divides B means this. This means this, right? So I can write it as like this: A into KA.
Sir, can you
Where
please
K
explain
belongs
again?
to N for all A belongs. Sorry. Here.
Sir, can you please explain again?
what I am saying. My question is, this is the relation I am defining on natural number where this A divides B. If A divides B, what does it mean? It means that B can be represented as like this. It means there exists an K in my natural number set such that if I will multiply that K in A, then I will get B. Right? For example, I will say 2 divides 6. When I will say 2 divides 6, it means that there 6 can be represented at K into 2, where K, what is the value of K? 3, right? 3 is a 6 now. That is why I can say 2 divides 6 or 6 is divisible by 2. Understood?
Yes,
it
sir.
means that B can be represented in the form of K. Now further I can modify this R as like this. R is equals to A into KA, such that this is for some K belongs to N and for all A belongs to N. Okay, why I am writing for some? Because there is a possibility I will get only one K. And there is a possibility I will get infinitely many K. I will let you know how you will get infinitely many K. If you will take A is equals to 0, then no matter what K you will take, you will also get 0, 0. Right?
Yes, yes,
so you
sir.
can get
Yes, sir.
infinitely many. So this is what. Now what I need to see whether this kind of elements are there inside R or not. What does it mean? It means that A has to be equal to KA, right? If this happens, this implies this,
Yes, sir.
right? Because second entry is what? KA. What does it mean? Right? I am taking this to this side. Take A as common. What you will get? This, since A is not 0 always, if it is 0, we have seen that, yeah, this happens. 0 can be written as K times 0. So 0, 0 is there. 0, 0 is there, we already know. Right? Now we need to check for those elements which are not 0. So it means that if A is not 0, so since both are real number, it means that one of the member has to be 0. A is not equal to 0, it means that 1 minus K is 0.
Yes, sir.
Right? So
Yes,
from
sir.
here we can get K is equals to 1, and 1 is a natural number. It means that we will always get such K. Right? It means that
Yes, sir.
AA is inside R.
Yes, sir.
Yes, sir.
Right? So this relation is a reflexive relation. Now understood?
Yes, sir.
I hope you understood what is the difference between reflexive relation and identity relation.
Yes, sir.
Right?
Yes, sir.
Right? So from here, the observation is that every identity relation is a reflexive relation, right?
Yes, sir.
Yes, sir. Right? This is one observation. Okay, Jasan, why no? Why no? You are saying every reflexive relation is identity relation, but vice versa not possible. Why every reflexive relation is a identity relation? That's my question. That's my question. Okay. Again, this is a reflexive relation. Jashan, see carefully. This is a reflexive relation, right?
Yes.
Tell me.
Yes.
This is a reflexive relation.
Yes.
Is this an identity relation now?
Yes, sir.
No, sir.
No, right? Because 2, 6 is also there.
Yes, sir.
2, 6 is also there, but 2, 6 is not allowed inside the identity relation.
Yes, sir.
So this is not an identity relation. Now understood?
Yes, sir.
Yes,
Okay.
sir.
Now I hope you understood up to this. Now let's move to the symmetric relation.
So why we should
See.
find K?
Why we should find K? Because we need to show that this AA is inside R or not. For showing R is reflexive, we need to see that whether this element is inside R or not for all A belongs to R. So firstly we have C for 0, 0 it's done. Then we see for any general element A. Okay, so for any general element A, we assume that this particular thing is inside R. So if it is inside R, it means that A can be represented in the form of Ka. So for that, I need to find this K. If this K is, I am getting something like √2, then it's not with the form, it cannot be inside N, right? √2 is not a natural number. If I am getting -1, this -1 is not a natural number. Then in that case, we will say, yeah, I cannot write it as in the form of K, where K is a natural number.
Yes,
Okay,
sir.
so that
Yes,
is why we have to see whether this K, whatever I am defining here, that K is exist or not. If it is exist, then it's a natural number or not. So from here, we have seen that, yeah, if you will take K is equals to 1, then all the things will be satisfied, and 1 is a natural number. Then I am done.
Yes, sir.
Understood?
Yes, sir. Thank you.
Okay. Now let's move to the symmetric relation. So what is symmetric relation? Same again, I am saying assume all those trivial things. R is said to be symmetric. R is said to be symmetric if and only if AB belongs to R implies BA belongs to R. Okay, what does it mean? It means that if such a pair like AB is inside my relation, then its symmetric part will also inside the relation. Symmetric part means just change the position of those two numbers. Okay, and why we can change this? Why we can change this both position? Because I am defining this relation on a set A only. Okay, if this I will define on A cross B, then if I will see BA rather than AB, then this BA will not be the member of A cross B. You have to remember, if B and A both are not equal to each other. Okay, we can do this kind of thing because we are defining this relation only on one set. Okay, understood?
Yes, sir.
Yes, sir.
Okay, so what is symmetric relation? Basically, the symmetric relation is saying if one kind of thing, this AB kind of pair is inside my R, then its opposite partner, sir, if you will change the position of two numbers, the first position and second position, if you will replace the position, then that particular element will also be the inside, will be the element of R. Then we will say this is a symmetric relation. Okay, got it? Now
Yes,
let's see the
yes, sir.
example. How we will see, suppose you have like this A, B, C, and now I am taking relation like this A, okay, AB, now BC, now BA, okay. Is this a symmetric relation? That's what I am explaining, Satya. That's what I am explaining. A relation is said to be symmetric if some pair is inside R, then its symmetric part will also be inside R. Okay, so my question is this R is a symmetric?
No, sir.
No, sir.
Why?
No, sir.
Because
Okay,
C
not
and
why. Okay, just listen to me. Okay, how many of you are saying yes, or how many of you are saying no? Just write your answer on comment box. Okay, those who are saying yes, just tell me the reason why it's yes.
So, because if A and A, it's just like the reverse also will be A and A, so it will be symmetric.
What about other members?
AP, BA, BC. Oh, so CB does not exist, right?
Yes.
Got it.
Okay. Okay. So if you get the relation, just take one element, and then see its reverse part is there or not. For AA, it's there, right? Because A reverse symmetric part of A is A itself. So A is there. Now let's move to the AB. Now see, for AB, its symmetric part is there or not? What is its symmetric part? Its symmetric part is BA. Now let's see, BA is there or not? Yes, BA is there. Now I'm done. Now let's move to the third person. So it's BC. Now check BC. The symmetric part of BC is CB. Now check CB is there or not? So CB is not there. So it's not symmetric. Okay.
Yes, sir.
Not symmetric. Now again, let's move to the same example. R, where I am taking AB, where such that A is divisible, B is divisible by A, or A divides B. Is this a symmetric relation?
No,
Again, write
Not
your
at all.
answer on chat box only. I just need to check whether you are actually getting the concept or not. Yes, who are saying yes, just let me know why it's yes. Just for example, if you will see 3, 6, here you can easily see 3 divides 6, right? Right? So 3, 6 is there in R, right? Yes.
Yes.
Yes, you are also correct. But 6, 3 is not inside R because 6 is not divide. 6 does not divide 3. Okay.
Yes, sir.
So it's not a symmetric relation. Okay. Okay. Another example on the natural number only. A equal to B. Is this a symmetric relation?
Yes, sir.
Yes, sir.
Yes, right? Why? Because this is basically what? A kind of element.
Yes, sir.
Right? And its symmetric part is basically A only. This is the identity relation as well as this is symmetric relation. Right? Correct?
Yes, sir. Yes, sir.
Right? So in that case, we can observe there every identity relation is a symmetric, right?
Yes.
What about the converse?
No, sir.
Converse is not true.
Not possible.
Converse is not true. Why? If I will include CB in this example, this will become a symmetric relation, right? If I will
Yes,
include
sir.
CB only, this will become a symmetric relation. But is
Yes,
this an
sir.
identity relation?
No.
No. Not even identity. Is this a reflexive relation?
No.
No, right? Because BB and CC are not there.
Yeah.
Oh, so this is what in symmetric relation. Okay. Now let's move to the anti-symmetric. What is anti-symmetric relation? So anti-symmetric relation is saying if AB belongs to R, okay, write all the trivial things, and A is not equal to B, then BA cannot be inside R. Simple. No, which is not symmetric. No. Why? Because I will let you know. Okay, I will let you know, Jason. This is incorrect. Which is not symmetric. It's incorrect. I will give you the example where that particular relation is symmetric and identity both. Okay. So what it's saying? It's saying, sir, if both entry, first entry and second entry, both are unequal or both are distinct, then if first this member is inside R, no, then the second member will not be inside R.
Yes, sir.
What you are saying, Satya? I didn't understand what you are saying. Okay, leave it. So what it is saying, if both entry are unequal, then if this member is inside R, then this member cannot be inside R. For example, if you have R like this, same for A, B, C, okay, and your R is like this, A, B, and BC. Is this a symmetric relation? Oh, sorry, anti-symmetric relation? Please write your
Yes.
answer on chat.
Yes.
Anyway, yes, it is, because for A, both are equal, don't need to see. Both are equal, don't need to see. Here, both are unequal. Now, let's see if CB is inside R or not. If CB is inside R, it's not anti-symmetric. Okay? If CB, since here CB is not inside R, so it's a anti-symmetric relation. Again, I am giving you another example. Now, tell me, is this a anti-symmetric relation? Yes. Is this a symmetric relation? So here, this R is symmetric as well as anti-symmetric. Right? So it's not like if some relation is just symmetric, it will not be anti-symmetric, or anti-symmetric relation is in a relation which is not symmetric. Okay? Okay? Now,
Yes, sir.
let's give another example. R. Similar example, AB, where A divides B. Now, is this an anti-symmetric relation? How it is symmetric? Because for symmetric relation, what you need? AB belongs to R. This implies BA belongs to R, right? Here, just take this AA. Its symmetric part will be A itself. Now, you can see A is inside R. Its symmetric part will be BB itself. So BB is inside R. So it's symmetric. Only two members are there.
No, sir.
Now,
He is asking why how it is anti-symmetric.
Anti-symmetric, what it is saying? It's saying if this happens and this happens, then this does not happen. If A will not equal to each other, A will be equal to each other, I don't need to worry about it. It can be inside R. Okay. If these two will be satisfied, then only I will restrict with BA element. Okay. If one of the thing will not satisfy, I will not going to restrict. Okay. He can do whatever he wants.
Okay.
If someone is my son, then only I will restrict for doing something. Okay. Otherwise, I will not going to restrict. Okay. So this is so what about this R? Is this a anti-symmetric? So you want me some example which is not symmetric and it's symmetric, right? Anti-symmetric. This is the example. The first one, where is it? This first one. This is not symmetric. This is not symmetric, but it's anti-symmetric. But how can we say that this one is anti-symmetric when there is AA in the relation which satisfy the definition for symmetricity for single element? The thing is, there is no such way. Like you cannot say if something is a symmetric relation, then it cannot be anti-symmetric relation. The anti-symmetric relation is simply saying that if some relation, if something, suppose 1, 2 is inside R. Okay. 1, 2 is inside R, and for which we can easily see 1 is not equal to B. 1 is not equal to 2. Both are satisfying. Then only you will go for 2, 1. then only you will check whether this 2 1 is inside R or not. If it is inside R, not symmetric. If it is not not anti-symmetric. If it is inside R, not anti-symmetric. Okay, if it is not inside R, then only you will say it is anti-symmetric. But here, but is coming. The but is saying if you are taking A kind of element, A inside R, here you can see both elements, the first entry and second entry, both are equal. Then for that, we are not saying anything. You are allowed. Okay. Okay, you are allowed to be inside R.
Yes,
We
sir,
are
I
not
got it.
saying anything. You are allowed. Now, for this equality case, if we will restrict, then that relation will known as asymmetric relation. But that is not in your course, so I am not explaining that one. Okay. In some relation, we will restrict this equality part as well. That relation will be known as asymmetric relation. But leave it. That is not in your course, so we are not going to explain. So what about this R? This relation, is this relation anti-symmetric? Do fast. It's already 10:32. Yes, it is anti-symmetric, right? Yes, it can be both. It can be both. In this example, see, in this example, if I will give this, yes.
Sir, but when we go through the standard definition of anti-symmetricity, it is like when A, comma B is in a set and B, comma is not in the set, then this will be anti-symmetric, right?
What you are saying?
Sir, the standard definition of anti-symmetricity is that when A, comma B belong to R and B, comma B does not belong to R. This is anti-symmetric, right, sir?
Here and is coming, and A is not equal to B. Then this happens. This second person you are forgetting. Everyone is missing this one. If this happens, if A will be distinct with B, if both are equal, we will allow that person. Okay. It's just like you went to the movie for watching movie in cinema. Okay, so they will say if you are 18 plus, okay, if you are adult, or if you are 10 plus, you need to or if your age is 5 plus, okay, if you are 5 plus, then you need to buy a ticket. Okay, then you need to buy a ticket. Now if someone is 4-year-old, does this person need to buy a ticket? He can buy a ticket. He cannot buy. He want. If he want, he can buy a ticket. If he want, he can. He cannot buy the ticket. Okay, he will not buy the ticket. Right? But does for this person they will they will stop this person to go inside?
No, sir.
No, right? He will go with his parents. And they will say, he is with me because he is 4-year-old. So he don't need to buy the ticket. Even he will buy a ticket. There is no concern.
Yes, sir.
So this is the case. Okay. So here, whenever we will use this if and then condition, so we will see whether the first one is satisfying or not. If first one is satisfying, then only we will see the second one. If first one is not satisfying, we are not worried about the second one. That's it.
Okay, sir.
Okay. Okay. So now let's move to the transitive relation. This is last. An equivalence relation is easy. So transitive relation is saying if AB belongs to R and BC belongs to R. Okay. Then we will say AC belongs to R. Okay, this is the definition. This is easy. So it is saying if AB is inside R, see the last element here, see the first element. Both elements are equal, right? First pair, the last element, second pair, the first element. If that kind of elements is inside R, then AC has to be inside R. Okay. So this is what. For example, you have set A again, 1, 2, 3 I am taking. Now 1, 1, then 1, 2. Is this a symmetric relation? No. Why? Because here see, second element, second entry and first entry both are equal, right? So for which I need to see 1, 2 is inside R or not. Okay. 1, 2 is inside R or not. So it is inside R. So it's a transitive relation, right?
Yes.
Right.
Yes.
Right. It is a
Yes,
transitive
sir.
relation. Why? We have seen we have only 2 elements. So we have seen the last entry of this, the first entry of this. We have seen that yes, both are same. If both are not same, then we are not worried. Just like that movie ticket example. If both
Yes,
are
sir.
same, then only I will go with this AC. If both entry are same, then only I will go with the this AC. If both are entry are distinct, I am not worried about it. Just like if I will give you this example. 1, 2, 1, 2 and 3, 3. Here you can see at any case, this entry or this entry, both are unequal, right? So I will not discuss about 2, 3 or 1, 3. I will not discuss about this because entries are distinct. What the idea?
Yes, sir.
Yes, sir.
Okay. Yes, this is also a symmetric relation, Jason. Sorry, transitive relation. Okay, so got the idea? Okay, so I am giving you another example. Just let me know, is this a symmetric relation or not? Is this a transitive relation or not? Is this a transitive relation?
Yes, sir.
It is. Why? Because if A is less than or equal to B and B is less than or equal to C. If A is less than or equal to C, B is less than or equal to C. This automatically implies that A is less than or equal to C, right? This
Yes,
is
sir.
automatically implied.
Yes,
Just
sir.
like 1 is less than or equal to 2, 2 is less than or equal to 3. Here we can easily see 1 is less than or equal to 2 is less than or equal to 3. We can write it as 1 is less than or equal to 3.
Yes, sir.
Right? So this is a transitive relation. So this is what about transitive relation. Lastly, equivalence relation. So this is nothing but if a relation is reflexive, symmetric and transitive, then we will say the relation is equivalence relation. That's it. If a relation is reflexive, symmetric and transitive, then we will say the relation is equivalence relation.
Okay, sir.
No, it's not a equivalence relation. Why? Because A cannot be a brother of A. I cannot be a brother
Yes,
of
sir.
myself. So
Yes,
this is
sir.
not reflexive. So this is not equivalence. Okay. So you can leave the class. It's already 10:40. Okay. Thank you. Thank you for joining the class.
Thank you, sir.
Thank you, sir.
Okay. Next
Thank
class
you,
will
sir.
be on
Thank you, sir.
most probably today TA session is there.
Yes, sir.
Okay. So just
Sir.
join that session. Yes.
Yes, sir.
Sir, you said you're sharing the document of this note.
Sorry. Yeah. Sorry.
Hello.
Yeah. I will upload. Just a minute.
Okay.
Okay. Just wait. I am uploading the document. Okay.
Yes, sir.
Please share this document. Whoever left the session, please share this. Okay, just open with OneNote only. Okay, this will open with OneNote only. So just download your OneNote software
Yes, sir.
in your laptop or in your mobile, and then try to open it.
Yes, sir.
Sir, where have you sent, sir?
Sorry?
Where did you send the document, sir?
I have sent. No, I have sent. Let
Yes,
me
sir,
see.
it came, sir.
I'm able to pin
Yes,
or
sir,
not.
it came, sir, it came, sir. Just wait for a while.
I cannot pin, I think. No, I'm not able to pin this. I have sent it.
Hello, sir. Okay.
I sent it. I sent it.
Hello, sir.
Yes, yes, yes.
Sir, where can I get the recording of this class?
Just go to the YouTube.
On the official channel
Let
or
me YouTube channel. Now let me show you how you will get.
Please, sir. Okay.
Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay, so here just fine. IITM BS program. Okay. This is the channel, and this is the recording. Okay. Here you can find very first video. Okay.
Sir, may I ask some? Hello.
Yes.
When will week 2 content will release?
Today itself, someone are saying today.
It's released, sir. It's already released.
The mail.
It's released.
I think the week 2 content is already released.
It's released. Okay. All the best. All the best, guys. Okay. Bye bye.
Thank
Hope
you,
you
sir.
will enjoy. Hope you will enjoy the session.
Thank you.
Yes, sir.
Yes, sir.
Thank you, sir.
Excuse me, sir. Sir?
Yes.
Sir, actually, in one of the videos, actually, I have a small, image of that, a screenshot. If I'll just share that, and you can tell if it is correct or not. If it is correct or incorrect, because I think that's a wrong statement. Just 1 second, sir.
Yeah, just share.
Sir, when will be the next session of next class? Sir, will you
Sorry?
send the document again, sir? Can you send the document again?
Yes.
When will the next session of sir next?
Sunday. It will be on Sunday.
Yes, sir.
So I want to ask something.
Sir, I have sent it by the name Yagyesh.
Sir, functions, when functions will be discussed, sir?
In Sunday's class.
Sunday. Okay.
Excuse me, sir.
Yes.
Sir,
Can
actually,
anyone please send the document? Just a minute. Can anyone please send the document? Actually, it's not going from my side. Can someone please share that? Like document. Yes, it's done. It's done from my side. You can check. Yes, someone was saying something.
sir, actually, my query is like, I I didn't got the link for the live class. So how can I get the link for the live class?
Someone please share how you are getting the links from live class. Please, anyone?
From calendars.
Google
From the
Calendar.
calendar.
Yeah, from calendar you can see. Just check your calendar.
But sir, there it
First
was
save
not given
save
like
it to the
today there
calendar.
will be class. There was given like on every Tuesday or Wednesday there will be live class of maths, not like today. It was given today there will be statistics and computational thinking.
No,
Bro,
Akshat,
check your
Akshat, you have to update the calendar for each and every course. Then that will reflect in your calendar. So go to each and every course. There is a specific calendar that you need to update.
Sir, what did you taught today?
Today math one.
Sir, which topic?
Relations, function, relations, sets. Yeah.
Sir, are you the same who teaches in video?
No. They are professors. I'm an instructor.
Okay, sir. Sir, my one question is also there. Like, after every video, there is a practice question given. So, in that practice question, only the correct option is given, not the detailed solution is given. So, like, if I have any doubt, so how can I get the detailed solution?
Just ask for TA for that. They will give you the solution. Or just ask whatever doubt you have inside the class.
Okay, sir.
Okay. Yes,
Sir,
I see.
send the-
Yeah, it's correct. It's correct now. A
you see-
divides B if A mod B is 0. It's correct.
Sir, can you send the document as link, sir? I can't able to download from here.
Sir, if this is correct, then there is in the same video there is one other statement. I will share the screen. Screenshot for that also.
Yes.
Sir, can you send the document as a link, sir?
As a link, I
Because
can't.
I can't.
As a link,
I
I
can't
can't
able to-
because I have only this document. How will I send as a link? Just download it, and you for open it, you need to download the OneNote software. Then only you can access. Or in the
Okay.
last term, someone was a good student. He was converting that document on the PDF form and he was sharing. If someone is there who can do this, they can. They just do this. Just convert this document to the PDF and then share with your friends.
Okay, sir.
Where is the document, Ji? Can you please send me the link in the chat box?
Pramod has sent now.
Sir, I have sent that other screenshot also. Are you able to see it from
No.
Yakesh?
Only one. Yes. So A divides B if B mod A is 0.
And sir, C, check it with the first screenshot. Compare it with the first screenshot. So
Okay. Just a minute. Just give me a second.
Yes.
Can you please share the document once again, please? We came just now.
Someone please, Pranod, can you please share once again? See, A mod B is equal to 0. It means what? A mod B is equal to something is what? What does it mean?
That means
Sir,
the
it means that A B is able to divide A completely. If it is 0.
What I am saying, A mod B is equal to K.
Is equal to K. Okay. So this means that when A is divided by B, we get a remainder K.
Okay. When we will divide B, and when we will divide A by B, we will get remainder K, right?
Yes.
Right?
Yes, sir.
So it means what? A can be represented as some R times B plus K.
Yes, right.
Right? So in this case, K is equal to 0.
Correct.
Right? It means that A mod B is equal to 0. This is what, right?
Yes, right, sir. There is
So
no
this
remainder. It completely divides it.
Yes. So this is one thing. And here what it is saying? So A divides B if B mod A is 0. So B mod A, it means that, so in that case, A equal to B.
No, sir. Sir, see, my point is that in both the screenshots that I've shared, in one of them it says if A divides
Bro,
B,
it's like when sir
A mod
explained it
B is
first
equal
time.
to 0. While in the other screenshot it says if A divides B, then B mod A is equal to 0. So both are different, right, sir? A mod B and B mod A.
Yeah, you are correct. You are correct. I think professor have made mistake. Just look at what he
No,
has
sir,
written.
it's correct, sir.
What he has written. There is a possibility there will be some tongue twist kind of thing. It happens. It happens in general, right?
Sir, when sir explained that for the first time, they took an example. And for the
Sorry?
second time, they just summarized it there. So they
Yeah,
just
there is a
wrote
possibility
that
that
in that way.
the tongue
That's
twisting thing
correct,
kind
sir.
of thing will be there.
Yeah.
Those
So, sir,
both
this
are
means
different
that in the summarizing in the end, which is if A divides B, A divide B means that A mod B is equal to 0 is incorrect, right? It
Yes.
should be B mod A.
Yes. Just give me a second.
Bro, try to grab the concept, not the literal, like the text meaning. Sir was explaining what mode represented. They was trying to say that whenever there is mode, B mod A, then A divides B. And the
See,
remainder is
basically,
zero.
what does it mean? A mod B, it means that whenever we will divide A by B, then whatever remainder we will get, that is showing A mod B. Okay.
Correct. Right, sir.
Right. So here there is a possibility they will get confused. See, it happens. They are also human. They can make mistakes. Okay. So just try to grab the concept only.
Yeah, sir. That is fine, sir. What I just wanted to understand all that is it is a mistake only, right? I mean, it is
Yeah.
not that both cannot be correct.
Yeah,
Either
because if
correct or
if B mod A is 0, it means that it means that we will directly divide. B can be represented R into A. B can be represented as in the form of R into A. Now A divides X 1 second.
Yes, sir, sure.
It's correct, I guess, right? If B can be represented as in the form of R into A, yeah, it's correct, no?
So what is
correct.
the second
Both are
screenshot is correct, but the first
Yes.
one is not correct, right, sir?
Yes. The second one is correct.
Second one is correct.
Yes.
Fine, sir. Thanks. Thank you so much.
Sir,
I also got confused. Now it's correct.
Sir,
Yes.
they both are correct, sir. Sir was just taking two different
Hello.
examples.
No.
Yes.
Ishan, both are not correct. Both are opposite to each other.
Bro, can you understand Hindi?
Can you tell how both are correct?
Just a minute.
Can I explain it in Hindi, bro?
Yes, you can. Don't fight here, okay? There is a possibility that there will be some
We are just,
mistake.
sir, when जब सर ने फर्स्ट टाइम वो जो बताया कि एक सेकंड मैं स्क्रीनशॉट ओपन कर दूं.
आपकी आवाज थोड़ी कम आ रही है, आप नहीं, या थोड़ी सी साफ नहीं आ रही है.
देखो, जब सर ने कहा कि इन समरी पीपीटी पेज यू आर
लास्ट में एंड में
ए मोड
के एंड में,
तो द कंसेप्ट इज कि जब सर कह रहे हैं ए मोड बी इज 0, यानी कि जब बी जो है डिवाइड करता है ए को, तो जो रिमाइंडर है वो 0 है.
ए मॉड बी का मतलब तो हुआ कि ए डिवाइड बी डिवाइड कर रहा है ए को, बी डिवाइड कर रहा है ए को.
Guys, listen to me carefully. Okay, can you guys please discuss after the class because it's taking too long. Okay, the class is around 4 hours, so we are not allowed to take that long classes, but somehow I am taking. So could you please discuss this thing outside the class? If you really get like if you have doubt, you just ask in the next class. Okay. Just share your number and share whatever contact you want to share, and you just discuss with yourself. Okay.
Thank you, sir. Thank you.
I am closing this session.
Thank you, sir.
Bye.
Bye, sir.
Thank you.